Oh my, good to see you. Good to see you. Have a seat. Take out your pen, take out your book. Let's get cracking. Earlier today, I made this post. Now we're gonna have a quadratics clinic. We're gonna be doing everything in quadratics for a secondary school Form 5 student. We'll be starting off with the insy bitsy baby stuff from CSEC maths, and we'll be going straight down into ad maths. So like maybe when we reach into the ad maths section, those who just doing CSEC maths, they will say bye-bye, good luck, and just leave the ad maths people to fight up with some of the hidden quadratics and sum and product things. So we'll just take a mini break there and come through with the hidden quadratics, sum and product, but we'll be going through everything for CSEC maths. I have no notes. I have nothing. I'm teaching this from the top of my head. I'll be going through everything. I have a very strong understanding of what you are tested on in CSEC in terms of quadratics and everything, and I'll just be giving you. I'll be starting out. This is the ideal class if you missed quadratics for some reason. Yes, ducking class or something. Ideal class to hang around in and just pick up where you can pick up and start to understand the real ideas behind quadratics. So without much further talking, I like this picture. It's color code thing. Nice. We will be starting. So let me just take a little look at the chat. I like to acknowledge the chat at the beginning. Hello, Michelle. Hello, Injustice. Injustice is a maths boss who already have his one distinction maybe in CSEC maths. Hello, Javish. Excuse me. Hello, Haley. Haley is a Form 5 student, AdMath student. Hello, Samantha, Dinell, all from my classes, and good day to the 209 other people joining us. I don't know how many people on Facebook. Facebook people, I like it say hello, I like it write why in the chat or something. Facebook, I like it. All right, so I'm linking it to Facebook. So I think that enough talk. This is brought to you today by the Student Hub. The Student Hub is my online classes, and we have classes in everything, including guitar, keyboard, drums, and social media, and makeup, and of course, all the other subjects, POA, POB, physics, maths, infotech, integrated science. So those who are doing exams next year, get in on this. The quality of teaching is the best in the Caribbean, can match the best in the Caribbean. I'm gonna put it that way. It's not so exclusive, but we really put in your look. So you WhatsApp this number and you organize yourself. Thank you, advertisers. Now let's get into our stuff. So I'll just bring up my here's Javish giving you all the number to contact there. What I'm bringing up is my whiteboard. It's not a good sign when I'm sticking to say words and all kind of thing. I mean, I'm not in my normal, 100% self. But we can still make it happen, and it's also not a good sign that I'm not seeing my iPad pencil. Excuse me, once I go behind the green screen here. This is a green screen here, and not actually by a brick wall. So this is a green screen here. Yeah, just looking for a pencil. Yeah, they give me a little chance then now, right? Sorry. I wonder if I bring this thing, right? Oh shucks. I think I picked my pants pocket and then I sneak it inside here. This is an iPhone 12 I'm giving away to one of the students in the Student Hub. The Student Hub is the place to be now. I still a whole year and then a little trying to sign up. You know much people trying to sign up right now for this year? When class is done, sign up now before. Sign up early, don't try and sign up 1 month before exams start on again. We won't start talk. By the way, I just want to say that I am in love with this person here. I am in love with this person here. Go and tell all your parents are in love with a student here. Right? So, Lubia Springer, I'm in love with that person. All right. So let me get started. We take a little too long to get started here. Um, so what we doing? What we doing? What we really here to do? We're here to do quadratics. So quadratics. That's how you spell the word first to begin with, right? And next up, what we should know about quadratics, but how it look, how it. Do you mind if I write like how I talk? How it does look. How it does look. How a quadratic does look. A quadratic does look like this: 3x squared plus 4x plus 12. What you're really looking at, the key in the quadratic is this highlighted part here, the x squared. That means one of the variables. Sometimes it could be y, like I could change everything here over to y. The variable part must be raised to the power of 2. The highest power of the variable is raised at is 2, or that is 2. So it must be raised to the power of 2. Why is in the chat if you understand that? So can you tell me something? Is this a quadratic? Should I tick that box? Is this a quadratic? Should I tick that box? Is this a quadratic? Should I tick that box? Well, this first one, I mean, they baby things in it. Yeah, it's a quadratic because it have a square. This one is not a quadratic because it have no square. This one is a quadratic because there's a square. Now, if there's a square and then there's a cube, then I have to untick the box. This is not a quadratic. We actually call it a cubic equation. Rate how much you understand everything out of 10 so far. So that's just identifying what the quadratic equation looks like. I kind of mess up my green screen there, and again, my own stuff fancy thing in the corner. Also feeling warm, but the maths must go on. So not only you should know how a quadratic looks, you should be able to identify the parts of a quadratic. Starting to get little secondary schoolish now. We out of the primary school life here. So like if you have 2x squared plus 4x minus 10, a quadratic is in the general form. There's something we call the general form of a quadratic. And we identify each of the coefficients and we give them names, A, B, C. I hope my language is not confusing y'all. And Michelle has it right here. Well done. So we have it in the form ax squared plus bx plus c. So if I ask the chat, what is the value of a, b, and c in this example, you all should be able to tell me. A is the coefficient of x squared, b is the coefficient of x, and c is the coefficient of nothing. The coefficient of x to the power of 0, which is 1. C is the coefficient of actually 1, or x to the power of 0. C is the number by itself, also called the constant. So it's very easy, and the chat has it here. Well done, Arian. I'll just put it, Haley. I'll just put it up, Arian. You won't just get knocked out. A is 2, B is 4, and C is negative 10. Easy, right? Everybody understand that. They could bring it a little tricky. They could probably do something like this. They could say maybe 4 minus 3x, and this is normally tested in like form 2. Why I can't count? This is not a good thing. This is not a good thing. I could be in problems so later on. I hope I pull through all, yeah. I want to give you all 3. Y'all can just write it out here, and the first person with the correct answer for all of them in one comment, I'll just pin your comment. So for all of these, I want you all to tell me the values of A, B, and C when you compare it to the general form or the general way a quadratic looks. Now, we like these kind of general forms in maths because we're able to use it for in the future, like when we're referring to how to factorize and things. So generally, a quadratic must look like ax squared plus bx plus c. All of these quadratics look like that, but you need to figure out where the a, the b, the c is. All of those are quadratics, and they have a, b, and c in them, and you need to figure out what is their value. So let me just write it here in what color looking good for today, boy? Blue. I remember not to exert my voice too much in case this class end up long, and my voice will rip up by tomorrow. I actually have one last makeup maths class with some of these people in the chat as well here tomorrow with my paid premium classes. And then I start over new in July. Registration is new for July for my maths class. Now, one of the common questions I get asked is, Sir, wait, Ariane finish all? So with your classes in such high demand, would I be able to get, one-on-one attention? That's one of the questions I get asked. But yes, the way I structure my class, yes, you will get is the best value. Best value you could spend for 200 a month. So let's check Ariane, whatever. -2. Does she have that for the first one? No, she doesn't. So I will have to take that off my screen. Let me try Haley. Right. So A is actually -2. Y'all understand that A is -2? Y'all understand that A is -2. Now you're looking for A here because A is like the first term here. A doesn't have to be the first term. A doesn't have to be the first one, guys. Ooh, I hope my thing not glitching out. A doesn't have to be the first one. A is actually the term that attached to the x squared. So if the x squared decide to move here, A is -2. Look out for that. So B is the one in front of x. So B is -3 and C is 4. You all agree with that? Nice. Here's a student from my class here. All right, so the next one is -4, and B is I lost Haley comment. Where Haley comment? All right, let me use the next student from the class, Isabella. Isabella normally get everything correct. Even if I make a mistake, Isabella get it correct too. -1 and 10. Does she have that for number 2? Kind of hard to make out for me right now. Yes, she does. And this one, A would be 1, B would be 5, and C would be 0. So there is still a C. It's just not A. It's just like you add 0, right? So someone asks, why not put a little x squared here? That x squared had nothing to do with nothing. We're talking about the coefficients. We're talking about the numbers in front of x squared, the numbers in front of x, or the number that's by itself. And the number by itself in front of x squared here is 1, like a silent 1, right? Number here is 5. Number in front, well, there's none, so you just put 0. It's 0 is still something. Nothing is something. And this is 1, and this is, we have to be careful here. B is, let's see if Isabella got it correct. B is actually 0. Well done, Izzy. And C is -25. Rate how much you understand all of this out of 10. So those who just joined, nice of you to join. Can you just take a quick screenshot and send it on your social? Let people know we're going through the entire quadratics. You may sit in school this year, taking it from the scratch. They could still come in now. We're still at the basics level. So let's continue. Just like how the transformers, that we're trying to draw here, boy, as a truck. The transformers could be in a truck, and then they could be in Optimus Primal. Yeah, it could be in the robot form, They could transform between forms. Quadratics can appear in two different forms. Is he come off my screen, please? Nice. So the quadratics can appear in two forms. Quadratics can appear in two forms. Can appear in more than two forms. Could appear in another form. Maybe a plane. It could turn into a plane too. It can appear in other forms. I could start off with like this. Let's put 2x plus 1 and x minus 1. And it mightn't look too quadratic-y, but this is actually a factorized quadratic. And it is quadratics about D here. Quadratic. It's actually a factorized quadratic. I could expand to go into the general form or the standard form. As well, general form. I could expand it. And that is one of the tricks that you need to learn in the basics. So this is something that a good maths teacher will usually give you like a whole set of homework on this. Anybody remember getting a whole set of homework and expanding these things back in form 2, form 3, and you had to multiply this by this and that by this, because you need to get kind of if they didn't give you a good amount of homework, they give you a way to practice this a lot. You need to get, good practice in expanding that and not making mistakes. So let's go through the expansion of this and see if a quadratic is going to pop out for us. So people call this the FOIL method. 2x by x, you get 2x squared. 2x by -1, you get -2x. You all keeping up with me? 2x by x is 2x squared. You need to understand indices if you don't know what happened there. And 2x by the -1, it's important that this negative be we understand that the negative belongs to the 1 here, So the 2x by the -1 is -2x. And we do the same thing with the 1. The 1 by the x is 1x. And the 1 by the negative here is -1. These two terms will always be able to simplify because they have x's here. Both of them are the same thing. This is like -2 apples plus 1 apple. Directed numbers, if you don't understand directed numbers, you need to go and review directed numbers before you even start with quadratics, right? Quadratics is like an intermediate topic in for CSEC. So that's you there. This is what really going on here, boy. Some of my things not saving. See? I just write something and it didn't save. Not good. So just give me a second while I disconnect and reconnect. I'm going to turn it off to change the connection. Quit it. Right. See what up to my sprang course. And there we have it. Nice. Pages transform and this that way. All right. Yeah, so we back up. Let's do a couple more now. You all can expand. So expand the following. Quick little exercise here. Y'all, I hope you all have your books out and you're working with me. 2 plus 1. Even if you're in like pure maths and you need this little extra revision, even if you're in ad maths and this feeling like really simple stuff to you, I don't want to pass square there. Let's put 2 negatives so we know what will happen when stuff like that occurs. So how about we do these 3? 3 sound good enough. To me, expanding to go to the quadratic is simple. Is there anyone fighting up with this? Anyone fighting up with this? Everybody understand this, right? Give me the little vibe check there, rate out of 10. I'm just going to do the first one kind of extra, and then I'll just gun through the rest, right? So 2x by x is 2x squared. 2x by negative 1 is negative 2x. 1 by that is 1x. And then you have negative 1 here. You have to pay attention to the signs. And then you simplify. So you get 2x squared minus x minus 1. Right, so you see in high ratings. This one would be x squared plus x plus 2x plus 1. So this one will be x squared plus 3x plus 1. This guy over here will be 3x squared. You notice the pattern happening. So you need to do real plenty of this. You can even create them for yourself and start to do as much as possible. Let's take it fast. 3x by that negative 6x, negative 2x when you do this one. And this one, you get a negative multiplied by a negative, so it's actually positive 4 here. So you're going to end up with 3x squared minus 8x plus 4. So it's all well and good to go from this form to that form. It's just multiplying and simplifying and liking yourself afterwards, feeling like a boss. But the real challenge for students begins when you have to go from this form back to that form. Right? When you reach this normal, standard-looking general form quadratic, and you need to factorize it all the way back up. Before we do that, let's just do 3 more. Let's just do 3 more. Sometimes you could get something like this. What to do in that case? Let's use ruler, straight lines here, since we have that option. Sometimes you may be seeing something where it's like more mixed up. Let's not put 1. Let's put 3. Yeah. Sometimes you may actually just see a direct negative there. I'm really enjoying this one right now, but let me put the 1 still. And x 2x plus 2. Yeah. So what you all get for these really quickly? Well, this one, it's actually less work. You just need to do one of the expansion. This is called distribution. So this is 2x squared minus x. And this is also a quadratic, and you just stop right there, right? These quadratics are easy to go back into that form. You just do a normal factorizing. Here, we go back to our traditional method. Pay attention to what's going to happen. You have x, you have the x multiplied by the 2 first. So you have 2x, then you have negative x squared, then you have 6, then you have negative 3x. So it's a little scattery. So check the last number 2. He accidentally left out 2 in the second one. And the second one, 2. Yeah, I left out 2 here. X by that, right? X, yes. Thank you. So negative 6x. Negative 3 by that, negative 6x. Wait, we didn't simplify this one yet. Yeah, so simplifying this guy, seeing the negative x squared there. So you could put the negative x squared in front, and you could have negative x when you combine these two together, negative 3 plus 2, and then you have the plus 6 here. How many of you all had it like that? For this one. Yeah, I've seen people with it like that. Or you could have had it like this. You could have put like the 6 in front, negative x squared. This is the same as this. I just rearranged it. Yeah. And then we have plus 2x and plus 2. So we have negative 6x squared. Yeah, I understand. I just multiply out here. The only thing that really happened in here differently is the signs. Somebody trying to call me all kind of thing. Negative 4x plus 2. And you could rearrange it. You could have like 2 negative 4x minus 6x squared. Well done. Well done. Ariane, redemption. So we just learned how to expand. And this is like, as I said, form 2, form 3, depending on your school stuff. Now the trick is taking one of these and going back up. So let's take this one, 2x squared plus 3x plus 1. 2x squared plus 3x plus 1. There's the very popular AC method that is used, and that's what I'm going to show you now, to go from this straight up back to the factorized version of the quadratic. Now, the factorized version of the quadratic, when it looks like this, is in most cases more useful for us. It's more useful for us. We can do stuff with this. We can go forward with it. We can easily find the roots. That's the main purpose. We can easily find the roots from this version. We can't readily find the roots from this version. So that's why our aim in a quadratic is to get it from this to be able to find the roots. In fact, one of the popular questions in CSEC maths in question 2, normally part A, is to factorize a quadratic. So this is learning 2 marks in your paper coming next month. How to get this to look back in its factorized form. So I'm going to show you just 2 methods today. The method for factorizing it using the AC method, and how to do it on your calculator to verify, which is a nice, sweet method that a lot of people are not familiar with. All right, so let's go. The idea is you want to multiply A by C. A by C. And this is something you want to practice so much you can do it in your mind very quickly. So you're multiplying A by C. Now you might be saying, what is A, what is C? You all remember? Come on. Okay. I did not have that first few slides that I did earlier up. That's the general form of a quadratic. So the A by C is the term in front of the x squared multiplied by the number by itself. So I'm going to put what's going on in my mind on the side here. A by C is really 2 times 1, which is 2. Immediately, my mind is already thinking about all the factors of 2. So when you multiply A by C, you start to think about the factors. Fortunately for us, 2 is a prime number, a really small number, with only 2 factors, 1 by 2. So it means some combination of 1 by 2 must be used to find the middle term. That's the next part of this method. You want to, your aim in life, when factorizing quadratics, is to find 2 numbers. We normally call them M and N. Your teacher would have normally called them M and N for you. Here is he giving you the rundown. Your aim in life is to find 2 terms, 2 numbers. We call them M and N. And these 2 numbers, when they multiply, you must get back what you get for A times C. And when they add up, you must get back what you got for B. That making sense? So one of the ways your teacher might say is M plus N must be equal to B, and M times N must be equal to A times C. Now, I don't want to confuse anyone with all these M and N and B things, so it's best seen in practice. Keep in mind, we just multiplied the 2 by 1, and we got 2. And I'm saying that I need to split this up into its 2 of its factors, a factor pair, that will add up to give me 3. And it's very obvious that it's going to be 2 and 1. Let me put what's in my mind. This is happening in my mind, people. 2 and 1. Because if I multiply 2 by 1, yes, I will get 2. And if I add 2 and 1, I'll get 3. So what do I do with this 2 and 1? What do I do with this 2 and 1? Here's what you do. You put back the 2x squared, you put back the 1, and this term in the middle here is going to be hacked down the middle into the plus 2x plus 1x. Why is in the chat if you understand that? If anybody have any questions, now is the time to ask, because we're going to just keep going forward. You all understand that? So it's like I'm taking this 2 that I just discovered and this 1 and separating the middle term. Yes, I'll be doing quadratics. So someone asks, so will you be doing quadratic graph, finding roots, intersect, minimum, all them stuff? Everything is a long session today. We just in the easy land for now. Continuing, I'll be teaching everything in this kind of basic, talk to me like I don't know nothing method, right? So After you reach here, there's a factorization that you need to do. So I like to teach students who now learning this to reach this spot and then stop thinking quadratics and like in the realm of quadratics, it's so hard, and start thinking about just factorizing four terms. This is a technique that you have learned in Form 2. Most students, most teachers would have taught this long before they reach into the quadratics part. This is where you factorize four terms, something we call grouping. And what happens? You're supposed to treat this like two at a time. Now, so like look at this side, look at that side. Why isn't each other if you all remember that? So you're gonna look at these first two and factorize there. What's common? 2x. 2 is common, and there's an x that can come out of both of them. And then you put what's missing. What's missing? X plus 1. Tell me if you agree there. You'll agree? Once you get this, once you get this, and if doing it properly, you can take that and just train back there one time. That's what it's supposed to do. So you take that x plus 1 and just swing him there one time. You're factorizing by grouping method. You did it correctly. Once you do this first part correctly, you're set up for this. And what I did there is just sneak in a 1 because that number needs to come in here that will multiply by this to give me back there. Let's group him up now. So we have 2x plus 1 by x plus 1. Now if we swing back for them, we realize it's the same thing. We just have it in different order, which is okay. It's commutative. So let's take a next one. Let's take one that's looking a little more challenging. Let's take this 3x squared minus 8x plus 4 and try to do the same thing. We finish. We factorize. Thing max, 2 max. These are 2 max. So we're going to take this one, 3x squared minus 8x plus 4, and we're going to try and bring him back. 3x squared minus 8x plus 4. First thing first, multiply the a by the c. You get the 3 times the 4. You get 12. All of that happening in my mind. I just putting it down there for you. So the a by the c. And I'm looking for the factors of 12. 12 has a lot of factors. In my mind right now, I'm just seeing this. And I see them in terms of pairs. I think one of the problems that happens with this, when I'm teaching students who fail maths like 2, 3, 4 times and they're talking about how they learn this and thing, is that they keep tackling this number first. So, okay, they know they need to multiply the a by the c, right? They get the 12. And what you start to do again, you start to get 2 numbers and multiply to give you this, but the numbers must add to give you that, right? By the time they finally learn that, 2 numbers to multiply to give me this, add to give me that. So they start thinking about numbers that could add to give me 8. No! Don't watch the 8. 8 is problems. Don't watch the 8. Watch the 12. Start to think about the 12 factors. And I'm seeing people putting the answer there already. Start to think about the factors of 12. This one is the key. The a times c, the number that you get there is the key for getting the 2 numbers. There are unlimited numbers I could multiply to give, to give me negative 8. Do you know that? I could add negative 9 and 1. I could add negative 10 and 2. I could add negative 4 and negative 4. I could add negative 3 and negative 5. There are unlimited combinations. So if you're looking at this, you have to keep glancing. Better you just start with this one. You agree? So you're starting with the 12. And in my mind play through all the factors of 12. And as I play through the factors, I just glance in here. What is happening? What could add any factors I get? Like first factor, 1 and 12. That's the first one to think of, the 1 and 12. That's the most missed one. But 1 and 12, there's no way I can get that to make negative 8. So next factor. The next one will be 2 and 6. 2 and 6 is 8. Negative, negative 2, negative 6. Negative by negative is positive. Bam, that's the answer. So negative 2. And if I didn't get the answer there, I think 3 and 4. 3 and 4 is 7. No way I could get 4. So you had to play that wrong. See if maybe I had to subtract both of them negative, both of them positive, 1 negative, 1 positive. Feel it wrong and see now. But the best idea here is negative 2, negative 6. Agreed? And it's only one idea could work actually. So it's going to be 3x squared. And I'm going to split the middle term, negative 2x, negative 6x. Then I'm going to factorize like a boss. There's no number that's common here. So I'll have to take out just the x alone. And then remaining will be this. And I can verify x by 3x will give me 3x squared. X by negative 2 will give me negative 2x. Now, a lot of people, as I said, they think this is a tough part. They train themselves to think that this is a tough part. Tough way to do it. It's not. This is this part of you just do the hard part. This is actually the easy part. And as soon as you understand what's going on here, you'd realize what if you're struggling. As soon as you get this, as I said, put it back one time and just try. Sorry, there's a 2 there, and just try and figure out what number to put here to multiply by this to give me that. And the answer is negative 2, right? Negative 2 by 3 is negative 6, and negative 2 by negative 4 is that. Then you want to do a little combination. I didn't really focus on this last time. You're going to combine this with this. And if you want to know the reason why, I'll tell you just now. And this with this. This is actually factorizing again. So this and this is the same thing, so I can just put one of it. Think of if I had 3a plus 5a. Really, I would have 3a plus 5a is 8a. I'd have 3 plus 5 by a. So in other words, I could take one of this and just put it there, and just take this and this and put it there. That's what's really happening. But you could just ignore that and just listen to what I say. I ain't leading you down the wrong road. That's the right way to do it. Rate out of 10, how much you understand this? So I just showed you how to factorize a quadratic 2 times. I'm going to show you 2 more times how to factorize the quadratic using this method. And after I'm finished with these 2 more times, I'm going to show you the best thing. I'm going to show you how to verify it and the recommended scientific calculator for CSEC. Many of the calculators you all have sitting on your desk can actually factorize, in a way, factorize a quadratic. All right. So we have a lot to do today. So let's do this one. Let's not do that one. Let's do yeah, I was looking for you. Where were you, man? Let's do this one. So we are here. 2 minus 4x minus 6x squared. And we want to factorize this. You might be saying, no, I wouldn't do that. I'm going to leave this video and I'm going to play. But then you'll be pushing back yourself, you know. You could do that. I mean, you could do that. 2 by negative 6 is negative 12. This is the A, this is the C. This is still the B. So you get negative 12, and remember I told you the focus in life is this. So I'm still thinking of 2 numbers I can just get together to organize a negative 4 for me. Nothing, nowhere again, 1 and 12 to do that. 2 and 6 looking promising because, yeah boy, 2 from 6 is 4, and again 4 here just to organize the sign. Since it's negative, let's make the bigger number negative. That's the trick. So 1 will be negative, 1 will be positive, and a hint with that is that the number I need to multiply to get back is negative. So negative 6x plus 2x is the Q. That's the way to go. AC method. All right, and then we're going to factorize like normal. 2 is a when you're factorizing, it's like you're watching it half and half. It's like there's an invisible line here, and you're dealing with this part first. So 2, 1 minus 3x, you all agree? 2 by 1 is 2, and 2 by negative 3x is negative 6x. Now, keep in mind, I didn't teach factorizing today, and I didn't teach directed numbers today. I expect that you have some kind of something, a little something in factorizing and directed numbers. Otherwise, this could not take real long, because I could do a whole workshop on directed numbers. That's like form 2, form 1 week. How did this appear in my recommendations? I am not even an English speaker. Well, you're writing decent English, so here you are. Remember, you all cannot use a calculator in the CSEC maths paper too. That's correct. But we're still going to show you how to organize yourself in the paper 1. So you put the 1 minus 3x here, because once you get this here, put it back one time. And then you put your plus 2 here. And I feel like our x could go there too. Don't forget the x on this one, because 2x by 1 is that, and then 2x by negative 3x is negative 6x. So this looking good. Then you join it up, 2 plus 2x. And 1 minus 3x. That is greatness there. Greatness. So you factorize. Let's do another one. X squared minus 25. In this case, you can do the AC method. But you want to say nah, because this is a quadratic that is actually adopting the form of something called difference of two squares. So you're going to put a little, stop in it here, pause, and I'm going to show you how to do the simple ones, the other ones on your calculator, and then you're going to swing back for difference of two squares and explain that, right? So the horizontal line test. Right now, we're not on that topic, though. All right. That's one-to-one, to show that it's one-to-one. Teach directed numbers, so can you group it differently? Yes, you can. But you must end up with the same thing, whether it's commutative, right? So one might be in front of the other one or the next one first, but it must be the same thing. All right, let's not waste too much time talking. So how to do this on your calculator, right? So say you could do this on your calculator. Well, what was the quadratic we had? What was the quadratic that we had? So I'm bringing up this calculator here. This is the recommended calculator. FX115ES plus, there's a new version to this. And your calculator will be looking at you like this. It wouldn't be in radians, it will be in degrees. I have the screen of the calculator here, right? So let's go back to this one. Let's say we're on this one. How to factorize this in your calculator? Well, your calculator cannot really, I didn't tell you the whole truth. I was like chemistry in CXE. You didn't know the whole truth. When you reach in Cape, you can find out the whole truth. So I didn't really tell you the whole truth. Nah, people. What happened in here is that your calculator can't really factorize this and give you the answer just so. Your calculator can solve it and give you the roots. And I'm going to come to that just now. If I go one step further and solve this, your calculator is going to tell you x is equal to 2. Or you could realize that x minus 2 is equal to 0. And I'm going to explain this. X is equal to 2. And 3x minus 2 is equal to 0. And when you solve that, you'll get x is equal to 2/3. The calculator can give you these two answers straight up. Straight up. So you're going to put this. You're going to press mode. You're going to press equation. You're going to press 3. You all seen it there? Ax squared plus bx plus c equals 0. That's the general form of a quadratic equation right there. So you're going to press 3. And then you're going to put in the coefficients. Look, they're literally asking me a, b, c. So you're going to put 3. You're going to put -8. And you're going to put 4. Then you press equal. You get the 2. And how this helping you factorize now? So when you see that 2 there, you're supposed to put x is equal to 2. Therefore, x minus 2 is equal to 0. That's the first factor. Understand? So you just use your calculator to help you just double check quick. Or if the quadratic looking like some big kind of hundreds or something, sometimes you see them thing in maths, pure maths. You just throw it in your calculator instead of fighting up with them factors. And x2 is equal to 2/3. So which is what we got here, right? So your calculator could solve quadratics. Yes. Your calculator can, even the sharp calculators can solve quadratics. Most scientific calculators that you spend a little money on that have the solar panel on them could solve quadratics. You just need to know how to do it in the mode. All right. On the sharp calculator, Isabella is showing you what to do. And she's a student from my AdMaths class. And she's a beast. Anyhow, so you have x is equal to 2/3. When you bring across the 3, you'll get 3x is equal to 2, and then you get 3x minus 2 is equal to 0. So you could get the factor out of this. What people normally do in their mind is just put the 3 by the x and then switch the sign on this, so it'll be -2. So you're seeing 3x minus 2 very quickly here. All right? On the sharp calculator, this is what you do. All right, so that's using a calculator. Let's go, and I'll try to put the things in the video in the different spots. We're going into the next topic that you must know, and also comes in number 2 in your CSEC exam. We're still in quadratics, we're in quadratics whole day actually. This is called difference of two squares. So I want you to probably put this not really in the part of your brain that you're studying quadratics on. You can just learn this off. This is something you just learn off, bro. It's nothing big. It's nothing big. Difference of two squares is easy man thing. There's one trick that could come and take away a 1 mark from here. Even top students just lost this 1 mark. I'll show you the one trick with difference of two squares just now. But difference of two squares is easy man thing. So you have like x squared minus 25. What they're saying is when you see a quadratic like this, and the big thing with this quadratic is that it's missing the b part, right? And to write this in a way that makes more sense mathematically, you'd say b is equal to 0. Meaning you not see no like minus plus 4x minus no. This part is not there. This part with the x not there. It gone, it missing. So when you see a quadratic watching you like that, just say difference of two squares. The difference of two squares really talks about finding the square root of this one and then finding the square root of this one. Notice how this is one square and this is another square. So this is the difference of two squares. So you need to find the square root to factorize. As I say, easy man thing. Ignore that negative sign. Just find the square root of 25. The square root of 25 is 5. So you find the square root of both of them, and the legend says is you take them now. You take the x, you take the 5, and you put them down next to each other like this. You make a plus between one, and then you do like this. And make a negative between them. And then you're done. That is it, you're done there. That's how this is work. Does this come in the exam? Yes. This exact same question comes for ZSEC before. Can it come harder? Of course. Of course it can come harder. So you can get something like 4, maybe a squared. Let's put minus 16. Let's not do that one. Let's put minus 49. So once again, we see in two squares. There's a square here, and what is this? There's a square there too. Well, yeah, so this whole thing is just one square. What is the square root of that? The square root of 4a squared. How this works is you find the square root of this part and that part and just rest them down. Square root of 4 is 2, and the square root of a squared is a. The square root of 49 is 7. My 5, you also know that. So the square root of 4a squared, that's going to be a line in this channel for a very long time now. Hey, adaptation in the dance. For those of you who are looking for accounting for CXE, this man has everything. So you can organize yourself one time. A word to the wise is sufficient. So 4a squared is equal to 2a. The square root of 49 is equal to 7. So now we'll have 2a minus 7 and 2a plus 7. But sir, I put the plus first. I do it like this. That's okay, bro. That's okay. That's you. Sis, if you want to do it like that, that's you. You get it correct both ways. Right? Everybody good at that? Cool. So can it come harder? Of course. So you can see things like with only letters. You can see like m squared, n squared. We have seen those before. Well, then your answer will be like this. Nothing to be afraid of. Yeah, then you could see stuff like maybe with the number behind and you're getting a little frightened. Still difference of two squares. Keep in mind, one is a square number. What's the square root of 1? 1. So you're going to put, this answer is going to be 1 minus 3b and 1 plus 3b. So you might be saying to yourself, sir, this is looking real easy. I could handle this. Practice it still. And there's one trick that I mentioned that can come with this, and I'm about to show you the one trick. Here's the one trick. Remember before I threw out this question, 4a squared minus 16b, minus 16? I want you to write the answer for this. And some people may write the wrong answer, and some people may write the correct answer. And the question is saying, and they always write this, they say to factorize completely. And they put 2 marks. Go ahead, give me the answer. G advance. Those of you all who from India and watching, this is not really on the G advanced level. When I'm doing pure maths and when I'm doing add maths, that's when I'll reach to that level. So right now I'm doing like CSEC. At the ending of this live, when we start to go into alpha, beta, roots, hidden quadratics, I'll start to be on this exam level. This is a tough exam. So yes, so I'll make sure and click like on the video. Yes, blessings. I'd put out the full answer there as well because he's a whole maths teacher. But some people may have been thinking to put this, right? Sorry to shine you up like that, Ananda White. But this answer here will only get you one of the mark. It's correct in a way. You did factorize, but they say to factorize completely. And this comes with CXC more times than usual. More times than not these days. It comes a lot with these kind of little small trick in them. And they will take you one mark. So you think you do the correct thing here? Because you did like the square root of 4a squared. And you get 2a. Then you did the square root of 16 and you get 4. And you do it. But sir, you tell me to do this. That's what you must be thinking, right? This is what you said to do, sir. And that's what I did. Well, that's not the whole truth. You're supposed to factorize completely. And if you looked at this a little more strategically, you'd realize that a whole factor could come out of this first before we even put on any action. A whole factor could come out of this before we put on any action. Adapt. Isabella is a different student, boy. Different. Right. So a lot of my students actually. 4a squared minus 16. 4a squared minus 16. What I'm saying, sorry for getting distracted. Another factor could come out even before we begin to put down the work. We can actually take 4 out of this and get a squared minus 4. And this is still difference of 2 squares. But lo and behold, we extracted a fraction. We extracted a factor first. And now we realize that we'll get a minus 2 by a plus 2. Another way to look at it, this is one way to look at it. There's like 3 ways. This is the correct answer, the full answer. Another way to look at it is if you got your answer before like this, you may realize that all of these have a common factor, 2. So I can take 2 out of this one. So I'll get 2 by a plus 2 by 2a minus 4. And then I can take 2 out of this one. So I'll get 2 times, and then this will go. Y'all understand what I'm saying here? So you'll end up with the 4a plus 2 by a minus 2. And Isabella comment on the screen something similar to that here as well. So you have 2a minus 4, 2a plus 4. It's the same as if you take out the 4, you take out the 2 out of one binomial and the 2 out of the next binomial. I just talk about these things. Yeah, and 2 by 2 is 4. Or to me, I think the easiest way to explain this to the average math student is just take out the 4. A squared minus 4. There's one other way that this can show up in your exam that looks a little tricky. One other way this could show up in your exam, like maybe you may see something like 8x squared minus 50. What would be the answer to this? So when I explained this earlier, I said you must be able to find the, you must be able to find the, what I said, boy? The square root. Yeah, the square root of these numbers. The square root of 8x squared. Must be able to find these. Wait, 8 do have a square root. 8 have a cube root is 2. 50 do have a square root. So the same thing applies. You're looking for a common factor. Generally, when you see this negative sign and you see 2 terms, you know it's some difference. That 2 squares thing they bring in number 2. So you need to just think about it. And if I take out 2 out of this, I will see 4x squared minus 25. And lo and behold, there it pops. There it pops. This 4 is a square number and 25 is a square number. And now I can simplify this to 2x minus 5, 2x plus 5. Verify this. Write this down. Write that down. Write that down. Right? Well done, Rahil. Well done, Rahil. So that's our little segue into difference of two squares. Can you rate difference of two squares out of 10? Does it come for CXC? What kind of percentage chances of difference of two squares coming for CXC? It's in the 90s. It's in the 90% chance that difference of two squares will show up for 1 or 2 marks in your exam. And it's an easy mark to not lose. So organize all yourself, please. All right. So let's take a look at my Instagram. Where was it, boy? That's where I had the information that I was supposed to do here today. As I tell earlier, I come into here with no notes, no nothing, and I just, living my life. I'm looking for Quadratics Clinic is the name of this thing. And general form, we talk about factorizing. We didn't talk about completing the square. Okay. Let me try and brace. Let me try and brace yourself. I'm going to that now. Completing this square. But before we go into completing this square, I feel I want to mention a little bit about the roots and solving. And like the idea behind quadratics, like the graphs and things. So I want to brace, kind of squeeze off completing this square and go into roots and solving and things. What your teacher mean when they're saying roots and some of the terminology that your maths teacher be throwing around with these quadratics and just quadratics and roots and solve and A, B, and C and I could tell you, like, even when I did CXCs, not all the terminology, the words that they say I really understand. I just learn off the methods and things. So I try to explain as I go along as if you don't understand none of them terms, right? So those of you all who just come in, we did like 50 minutes of the basic stuff in quadratics. And we want to look at like what gives some more meaning with quadratics. Let's give quadratics some more meaning. Let's give quadratics some more meaning, people. So we have ax squared plus bx plus c. This is the general form of a quadratic. Let's go into graph land. The lovely land of graphs. So if we have a y-axis and an x-axis, anybody know how the equation of a line looks like? Anybody know what the equation of a line looks like? This is exciting stuff, people. Don't run away. Don't leave me. Don't leave me. Don't leave me. So if we have like 2, 4, 6, 8, I'll give me a little chance to draw the graph now. -2, -4, -2, -4, skipping, counting in twos in case you didn't notice. 2, 4, 6, 8, 10. This graph is not going to be very nice, Cohen. Let's make the y-axis not counting twos. Let's make the y-axis counting fours. Aha. Strategy 4, 8, 12. It's counting in 4 thing is tough. 20, 0, -4, -8, -12 will be somewhere down there. I'll agree with me. Was any mistakes made? This is good. So people are telling me that the general form of a line is y equal mx plus c. We're not here today to talk about this. This is coordinate geometry. But that's correct. The general form of a line is y equal mx plus c. So if I did a line like this, this is technically this should be the line y is equal to x, but it's not. Why is it not the line y equal to x? Because I decided to do this kind of jokey man scale here. If it was 2 here, that would be the line y equals to x. But this is actually the line y is equal to 2x. Because I'm seeing 2 here, and when I go up, I get 4. I'm seeing 4 here, and when I go up, I get 8. 6, when I go up, I get 12. Why isn't it trying to follow with me so far? We're going somewhere with this. Believe it or not, we're going somewhere with this. This is a linear equation, and like if I shift this up a little bit like this, this is actually line y equal to 2x plus 4. I just introduced a y-intercept. Good stuff. I tell you, it's exciting stuff. That's how it come about, and that's how this y equal mx plus c thing come about. So it have a gradient of 2, and the y-intercept is 4. Or if I take the same line and shift it down like this, ta-da! Now it's the line y is equal to 2x. What do you think? Y is equal to 2x minus 8. All you agree? Everybody understanding so far? I'm going somewhere with this. I go in somewhere with this. Or if I take this line and I flip it around so it had the same look, and I send it through, like maybe let me send it through the 12. Just now I'll show you what I'm doing just now. And just now I'm doing important things here, and boom. All of a sudden, this becomes the line y is equal to, it's still going through a y-intercept, so let me put the y-intercept one time, it's 12, but the gradient going down, so, and it's the same gradient size, but it's negative, so it's negative 2x plus 12. So I just teach you a real thing there, real things I teach you. Now, why am I talking about this? Because quadratics have a place on graphs too, you know. We could model a quadratic graph. We could create a quadratic graph. A quadratic graph is of the form y is equal to x squared. And for y is equal to x squared, right? This is like this, the smallest, most basic baby quadratic you could ever think of is y is equal to x squared. That's a quadratic. Just the x squared by itself, raw. That's the smallest little baby quadratic you could think of. And if y is equal to x squared, when x is 1, y would be 1. When x is 2, y would be 4. When x is 3, y would be, come on, stay with me, 9. When x is 4, y would be 16. Now you understand why I wanted to use this this scale, right? So I could get a little, I could get some more points in my life now. Now, if I use the correcting to use the to show the points, what CXC like the x's, you see a little something playing off here. 4 squared, 4 is 16, 3, 9. You see a little pattern when x is 0. You all seen it? Are you with me? This, my friend, I have just created the quadratic graph. Are you seeing it? Are you do this before already in school? This is where it come from, the quadratic graph. The look, the style, the pattern. -2, 1 by 1. Oh, sorry, this one need to dip a little bit. That correct? This one need to dip a little bit. That is one there. Must scale. Because 1 is actually here on the scale. Anybody point that out to me? Let me see if Adapt point that out to me, right? No boy, Adapt. Yeah, I'm suffering out here. So this going like this. And this going like this. That's a quadratic graph. Ooh, that's an important call, boy. Sorry, if you're on the live and you make that call. So the only call I'm answering is the call from the person I tell you I'm in love with at the start of the live. So y is equal to x squared. I have just, stay with me earlier, I've just created the quadratic graph. This is how it looks. This is how it looks. Now, this graph could do all kind of things. I could do all kind of things and get this graph to change all over the place. But I have no time to draw that today. Instead, we will be bringing up a program that, and if you're a teacher here and you're just taking it in for, say, this is a program that you could use to bring joy into your children, them heart. You could put y is equal to x squared. And boom, you see the graph that we take so long to draw. There it is. What do you think about that? There's the graph. That's the quadratic graph. That's how it looks. I'm zooming out now. It's a really weird graph when you zoom out real far. If you zoom in, you're getting the quadratic look there. You're getting the quadratic look. It's looking nice. Now, if I put 2 there, what you all seen in the corner of the screen there? If I decide to put 2, the graph spreading out some more. Now you're getting thinner, right? Yeah, we're getting thinner. If I put like 19, you see what these kind of things that they must do. Play around with these things. So how to get this graph to move like down? well, I have to introduce the y-intercept. Like if I put plus and I put 4, the whole graph take off like a rocket and going up to 4. It cuts at the 4 now. This is exciting stuff. So what about if I'm creating that as a B term and then I put the 4? Well, the graph is still cutting the y-intercept at 4, but now because of the presence of this B term, the graph changed. And maybe if I make like this 5, this looking like a classic little quadratic here for me. Maybe if I make it negative, let's see what happens. That's the best. This is a classic quadratic graph that you'll be dealing with in CXC. And 4, negative, and negative. Yes, this can factorize. So this is a really nice quadratic graph. Now my question is for you. What is the root of this? Listen to the question. What are the roots of this equation? Because that's what we're here. We're here to understand what the quadratic graph is about. What are the different points of the graphs? What are the names and everything? One and 4 says Rahil, and Rahil is correct. The roots of this is 1 and 4. Y'all can see it. Oh, too far. I need to zoom in a little bit. I'm going to zoom in a little bit. Zoom in and pull down a little bit. Y'all see them numbers there? Can I make the numbers bigger? Ugh, they're not looking good. I like how this one looking. Right, so that is really, I had to squint. So 1 and 4 is the roots of the equation. The roots, when you think roots, what are you thinking? A tree. Every time I hear the word roots in maths, I think like a tree and the ground, and the roots cut through the ground, and like the ground is the axis and the roots is where it cut like something like that. I don't know what you think when I hear roots. What do you think when I hear roots? Your mind is reached that far, but the roots is basically where the graph is cutting the x-axis. Right? The roots is the numbers, the values of x when the graph cuts the x-axis. Remember, this is the x-axis. How do you feel, Rona? No cannabis, though. I can't believe I read that comment on my live. Anyhow, so x is equal to 1, x is equal to 4. Those are the roots of the equation. Those are very important points. If you plan on understanding quadratics and doing good in quadratics and CXC, you need to be able to, it's how people pin in people and thing. On my thing, I don't remember making that pin though. So let me see if that happens again. All right, so x is equal to 1 and x is equal to 4. Those are the roots. There are some more important points. Some key points in the quadratic. The y-intercept, Haley is already jumping the gun. Haley is pushing the pace of this class. So we have y-intercept. The y-intercept is 4. And anybody else want to tell me the other important point? There's Isabella running through with the other important point. The other important point is this guy here. It's not really shown on the graph. There's no spot showing it really. But that's a really key point. AKA the turning point. Let's talk about it. Let's talk about it. You see, we have the turning points. When we're talking about turning point, we're talking about a curve on a graph. The turning point is where the graph turns its life around. So it was going this way and it decided to turn so. The exact part here where the gradient is positive, 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 0. Negative, negative, going downhill, going downhill. You understand that? If you was walking here, I'd be walking up, 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 across. There's a tiny little point you'll be walking across, 0 gradient. And then you're going to be going down, down, down. That spot is called the turning point. And if you was going up the hill and then turn back and go down, we call it the maximum point. There's a special name for this one. Maximum point. Or if you were walking down the hill and then you start to turn up, we call it the minimum point. Well, you feel we call it maximum and minimum 4. That is where it comes from. This is the maximum point that the graph reaches. The graph will never get higher than this. This is the minimum point that the graph reaches. The graph will never get lower than this. If we talk in quadratic, that is. Some cubic polynomials is want to be doing these kind of things and things. Anyhow, so ignoring that, maximum point, minimum point, or the big word, we could call both of them turning points. Why isn't it chat if you understand that? So some other key points. Now, why do we need to know this? I don't know. There's just something there's just something there's actually to, I don't know, get marks or something in an exam. I don't know, right? So this turning point here actually looks like, let me see if I can actually get the value itself here. There it is. The turning point of this graph is, hey, I click on it just now. And all you have to click on it and they could bring it up, right? There it is. So the turning point of this graph is 2.5 negative 2.25. So let's just go back to the important points you need to understand with a quadratic. I start off and show you how the quadratic graph was simple, and then when you started adding other terms in it, it started to go all over the place. And if the graph happened to cut, if the graph happens to cut the x-axis, we call these points the roots. A quadratic graph, once it's extended throughout, it will always cut the y-axis at some point. Must. So that's the y-intercept, that's the number, that's b by itself. Even if you have no number by itself, that means the y-intercept is 0. And then this is the minimum point. And you must know about those 3, well, it's really 4 points in this case, but 3 things. The roots, the intercept, we're coming back to this. Remember, we're going to complete the square now. And the minimum point. Or I want to use the word turning point so it could, because sometimes the graph could go like this. Let me show you how we can make the graph go upside down. Let me show you. So, important points. 3 things, important things. Mark that down. Ready. So, how we can make the graph flip? Very easy. Just change this to negative. So, like if I put negative there, zoom out and watch what happen. Oh my gosh. Let's not make it negative 1, negative 3. Yeah. So if I put a negative integer there, all of a sudden the graph turns the other way. It has a maximum point now. And that is why we say if A is positive, you have a minimum point. But if A is negative, you have a maximum point. If this value is negative, that you can barely see it. That value is negative, the graph will look like this. It will generate a maximum point. Oh, sorry, I do that one here. The graph will generate a maximum point. If this is positive, the graph must generate a minimum point. Coefficient of x squared. Well done, Isabella. I had a per class by Cohen and Isabella. All right. So let's go forward. I think we're ready to do some completing this square. Now you might be saying that was real good. I find quadratics could just stop right there. And I could kind of agree with you. Yes, quadratics should just stop right there for this level of maths. You know, you're good. I know enough. This is as far as I really want to go in quadratics, but no, we now reach halfway through the journey of CSEC maths. They want to take you a little more. They want to take you into the land of completing the square. So what is completing this square? Remember in the beginning, I drew a truck. And I say quadratics could operate like transformers. And then I drew Optimus Prime. Yeah, that is MD. And I say it could transform from the truck into completing the square is another form. You could transform it to. Also a really powerful form. Or it's a form where we could find out the roots. So you might be saying now to yourself, why do we need another form? Because we went from something like, what we went from, like 2x plus 1 and x plus 1, and we square out everything. Let me put that 2 here, negative 2, some negative 3 to make it different. 2x squared, negative 6x plus 1x minus 3, 2x squared minus 5x minus 3. We entered here. We were here. So we know how to go from this to this, and we learn how to go backwards using the factorizing AC method or your calculator to help you out. We learn how to do the both. Kerwin Springer, any opinion on teachers who tell students not to use the formula for H and K because CX won't give you the marks if you do it that way? I'm going to answer that question soon. You will get to understand what the question is he asking there soon, right? So here we go. We have this. And we entered into this factorizing form, and we could get the roots from this. The roots is like x is equal to 3. And the roots is x is equal to -1/2. And I'll explain roots a little more just now, right? But this is remember what the roots meant. The roots mean where this thing actually cuts the x-axis. So -1/2 and 3, this is how this quadratic would look. And there's a minimum point somewhere here, and the y-intercept is -3. We learning things here. We're picking up things here. I hope I ain't going too fast. I'm going to explain anything that I didn't teach yet in quadratics. I am going to explain it. So just stay with me. So we have this already. Why do we need something called completing the square to be able to find the roots? Well, not all the time you could factorize a quadratic. So there's only the rare occasions you could factorize quadratics actually, and CXC just pick out those rare occasions and give them to you in question 2. If I create a quadratic, the chance is more than not I cannot factorize it using just this factorizing AC method. I need a stronger weapon, and the stronger weapon is completing the square. So what is this completing the square about? Now, when I teach stuff on my channel, I try to teach it so that everybody could understand, not only strong students. But completing the square gives teachers a challenge to teach, because it's so much different topics you're pulling from to understand. You must understand factorizing, directed numbers, all the basic stuff in quadratics. It's so much stuff to keep in mind, and it's just 3 steps. In 3 steps, I could complete the square. So I'm going to show you 2 methods. And I'm starting to segue into Sir's question here. I'm going to teach you how to do it normal. How to do it the normal, natural way, which is the way that most people here will not do it. How to do it by the method of perfect square. Like you're creating a perfect square and then you're completing the square, which is literally what the name means, completing the square. That's how you're supposed to do it. Then I'm going to teach you what a lot of people, if you're just normal level in maths, I'm going to teach you the formula method, which will save your life, my brother. And I'm actually going to show you the calculator method as well. I'm going to show you how to complete the square in your calculator. And in both of these methods, I want you to use your calculator and double check your answer in the exam. So you're going to complete the square using either the formula method, natural method, or it depends on the type of math student you are. And when you get your answer, double check it, or maybe even complete the square first on your calculator. That's what I tell my class to do. Do it first on your calculator, see the answer, write it down, and then work towards the answer. You're sure that you're going to get the mark. And the reason why I'm giving you easier ways to complete the square and not just this tough way for most students is because after you have completed the square, it's like this, the question. This is the journey of the completed the square question. It comes like 40% of the times. After you completed the square, you went from this spot to that spot. You collect, maybe the completed the square might have like maybe 7 marks these days. 7 marks. Do you know that sometimes you have to complete the square here for just 2 marks, and the other 5 marks in the question is just asking you about completing the square and different things you did when you complete the square? And if you can't complete the square, you lost all these marks. So I'm going to show you how to complete the square for sure. So you could get past here and be able to collect the rest of marks. Even if you get taxed a mark for using one of the not too skillful methods. But the only way they could take away a mark from you for using the formula method, or even just taking your calculator and write it down, is if they say by the method of perfect squares, complete the square. But if they tell you to complete the square and you use a formula that you have, that's mathematics. Mathematics is full of formulae. is the Pythagoras theorem is a formula. Nobody asking you to prove Pythagoras theorem and go through the whole long method with proofs and everything and then use the formula. You could take a formula and get to the answer. So formula method, 100%. All right, so let's go. That's enough talk. Let's actually do the thing. 2x squared minus 5x plus 5x minus 3. The first thing you need to know is that when you complete the square, it doesn't look like this. Let me show you what you're going to look like. This is the equation. We're starting off good like this. This is the equation. We're going to complete this square and end up in a form. Back in my day, or back in Sir's days, when you complete this square, the form that they used to use as ax plus b to b squared plus c. CXC now kind of stop using b and c here because it's just confusing the child with the b and the c there. It's not the same b and c. So instead of using b and c, we use the letters h and k. That fits nicely into our plan. But first, taking what happened here, I am telling you that we are going to take this equation and make it look like this. What all we learned to do so far is to take that equation and make it look like something like this. Wait, had a term there, maybe a plus and something there, something so. That's what we do before. Now we're going to take this equation and change it into this. How do we do that? That's what I'm here for. I'm going to show you how we're doing this, right? So we're going to do which method are you first? This is a democracy. The first method is the nice way mathematical, natural, pi perfect square method. This is the formula method. And when I teach you the calculator part last, which one allow me to do first? 1 or 2? Natural formula. My chat going and pop up with all the thing now. Formula, natural, formula, method 1, natural, normal. It kind of even, so I'll go with the natural first. All right. So you're taking out A. I'm just writing what's happening in my mind here. If you want to learn completing the square inside out, all right, fine. I'm going to teach it inside out here. Fine, because that's what I plan to do in this video, right? You want to factorize out A. So instead of factorize, I use the word whip out A in a video like 2 or 3 years ago. And I see teachers putting whip out A and all kind of thing now. And students know so. Like that's the official term in maths now, whip out A. So you want to whip out A. A is this 2. And I want to show you one time that I want to say to you today, one time that some teachers take out A from everything. I know about our life. Just take out A from the first 2 terms. In this case, it's going to get a little complicated, people? Because, and this is really nice for this. If you take out A as a demonstration and to show you like the full blunt of the full extent of this method. If we take out A, and we factorize it out of the first 2 terms, this is what happens. You put the 2 there, you open up a bracket and you put your x squared there. That's all well and good. 2 by x squared give you back the 2x squared. And if you take out the A from this term, problems in the dance. 2 can go into 5. So what we really do is just put -5 over 2, like that. And put back the x there. Verify that if I multiply 2 by this number, I will get back -5 because the 2's will cancel. So it works. And now you can just leave the 3 here. The 3 number, I nobody. Just leave him there now. So leave the -3 there, like that. Are you ready for the next line? Why isn't it chat if you understand that line? So the first line is to whip out A. Factorize out A. Out of the first 2 terms. I should put that. From first 2 terms. Now, I don't like to put first 2 terms because next thing is not a quadratic like this, but yeah, I'm talking freely here, right? From first 2 terms, you want to whip out the A. Factorize out A. Cool, everybody good with that. Now we're going into the more complicated part. And the problem with completing the square is the introduction of intricate fractions and squaring and that kind of thing. Listen to me. This term that we have here, we want to get half of it. Half of 512. So I'll check you back on the factorizing methods, all these fractions and things. Some people must be saying tune off and just wait for this man to read the formula method, because you see there's problems. But for those who paying attention and interested, if you want to get half of this, there's a shortcut. There's a shortcut to get half of this. So the shortcut to get half of this is just like squeezing 2 here. Like 2 by 2 is 4. So half of 512, half of 512 is 514. Notice I'm writing anything here, right? Because it's kind of going into my mind right now. So this 514 is interesting. Whatever we got here after we factorize out the A, we want half of it. And after we find half of it, we want to square that solely. There's a method to the madness. We want to square them. We want to square him up. So you're going to get 25 on 16. So am I saying, so what is the meaning of all of this? Why are we doing all of this? There's a reason for all of this. The idea with completing the square is creating a perfect square. So I'm coming back to the question, but I need to mention this when I'm doing this method. Creating a perfect square. Y'all with me? Y'all saying that? Y'all paying close attention? Just to recap to make sure everybody on the same page. All we did so far was whip out the A, and then I'm giving you some instructions. This term, and notice I'm not using any B and A or any letters or anything. I'm just saying this term. This term, whatever you got here, find half of it. And whatever you got there, square it up. You can do it on this side for now when you're practicing. Nice? This is supposed to happen in your mind. But if like a normal student, just do it on this side, right? Creating a perfect square. What do I mean by creating a perfect square? What is a perfect square? This is a perfect square. This is a perfect square. And if this side was x and this side was x, what's the area here? X squared. That's a perfect square, my brother. And if this was y plus 2, then this have to be y plus 2. What's the area here? Y plus 2 to be squared. This is a perfect square. It's perfect. It's just a perfect square. That's what I mean when they say perfect square, creating a perfect square. You see, this has some squaring going on, but it's not a perfect square. A perfect square I can just do that. And if you look really closely at the form that we're trying to bring this guy down towards, where did I write him? I know I write it somewhere. Anyhow, let me write it back. We're trying to bring it to this form earlier. We're trying to bring it to this form. What you notice here, this is a perfect square. So what we're trying to do, and I'm just telling you this so you have somewhere to rest your foot. We're trying to create a perfect square inside the quadratic. And this is the way to do it. A little more explanation. Don't remember, if they're struggling to keep up with this, we're going to come up to the formula method, which every student can be able to keep up with. But any of these students who are good with this want me to explain a little more on why you're creating the perfect square and how you're creating the perfect square? Yes? Yes. So, what do you notice about these perfect squares? Let's say I square it out, what's going to happen? X squared plus 6x plus 9. X squared plus 8x plus 16. I am not a very quick arithmetic person. I mean a quick. But I'm not exceptionally quick. There are people who are much quicker than me in arithmetic. But how am I working out this? I'm just saying x squared, and then I'm saying 3 squared to put the 9 there. So x squared, 3 squared. And then I'm saying 2 by x by 3. And I get that there. Instead of putting it like this and then doing my whole FOIL method, there's a shortcut you can do, right? Let me just show you the shortcut one more time. Like if you have something to be squared, you can say x squared, badang, 4 squared, 16, badang. and then 2 by x by 4 is 8x, right? That's how it's good. Right. So, but there's something that happened in here. There's a little pattern that's happening here. A little pattern that's happening here. Are you seeing the pattern? This number here, squared, well, there's a kind of relationship. There's a kind of relationship here. So if I go here squaring, but if I go here halving, well, multiplying by 2 then. But if I go like this way, it's like half, right? Are they with me? Are they with me? We're going to exploit this pattern. That's how we create the perfect square in this. That's why I say find half of this and then square the half of that. We are about to unveil the answer now. We're going to exploit that pattern. That's for the quick students who, really good in maths and they wanted to see a little more behind it. So we're exploiting that idea. And if I'm going to put something in here, that's what I'm going to do. I'll write it in red so it will stand out. I'm actually going to chuck this inside. For those of you who are not from Trinidad, I don't know if you use that term in other parts of the Caribbean. Chuck mean, sneak it in there. Or to poke somebody with something. So 25 and 16, it's there now. I squeeze it in there. Now it is absolute insanity to just put in something in an equation in maths and just say that equal to the thing from before. That's like if I had x plus 2, or like let's say if I had it's you, your boyfriend and girlfriend on another boyfriend plus girlfriend, and I just squeeze in side piece, and I say equal. That could never be equal, right? Like I can never squeeze in something here and say it equal. So the idea is that we're gonna put it in and we're gonna take it back out. That's what we're actually gonna do. We're gonna put it in and take it back out. So I'm gonna take it back out like this. Yes, but no. Yes, but no. Because you think that I just put in 25 and 16 here, but I actually put in 25 and 16 multiplied by 2. Because there's a 2 outside this bracket, it means everything had to get hit with 2. Or if it was 3, it will get hit with 3. So I actually need to multiply whatever I'm doing here by 2 first. So the quick way to do this is like 8, yeah? So I'm actually taking out 25 on 8. All right. Why isn't the chat if you're with me so far? Notice I didn't show you any formula. I just showing you how to do this in natural method. You'll come back at like 1:20 in this video and watch over the whole thing and practice with a whole star equations, and you'll just get it completely if you're interested in doing it this method. So we're good so far. There's one more line and we're done. This was the hardest line. This line that we do here to figure out this number. Hardest line. By the way, I want to tell you here today that we just created a perfect square on the inside. The perfect square is on the inside. The perfect square is there. How we know it's a perfect square? If we halve this and square it, we get it's a perfect square here. This is the perfect square. We created a perfect square. We created a perfect square. We completed the square. We completed this square. How much time I can say that? So it's time to just bring him home. And how do you bring him home? You just get half of this, or this number that we had there. You're going to put that like this. Notice how the square gone? The square gone. The square get liberated. It's a perfect square, so I can write it like this. This is that. And then, for all intents and purposes, you could merge this into one. To merge these kind of things into one quickly, well, you need to understand your directed numbers. And how I get the 25 on 8? Because I multiply this by 2. Because I add in 25 on 6 and I subtract it back out. But instead of putting 16 here, I need to multiply by 2. Any more questions? Yeah. So to merge this fraction into one, a little trick you could use is, like this is -3 minus 25 on 8. This fraction is out of 8. 25 parts out of 8. So if I want to take away an additional 3 parts, this is like taking away an additional 24 on 8. 24 on 8 is 3, right? 8 3s are 24. So in my mind, I would just like add on 24 to that and get 49 on it. That making sense to you? All right, so this is a good time for me to go over this 2-3 times with different questions, but I'm not going to do that. So what you'll have to do is search up Cohen Springer completing this square and look up how I went through it. Let me just pull up the video because I'm earlier really hardened, boy. Wait, completing this square Cohen Springer. Search it like that on YouTube, just like that. Bang. And I have a series of videos on completing this square Cohen Springer. There you go. This one. This is the one that I want. This is the one. It's just 14 minutes and they're going through a past paper question and everything. So mark that down if you want to learn that natural method. All right. I think it's good time to show you all the other way to go from this to this. Now, when you reach here, you normally write this to look like a big boy out here in the form a into x plus h to b squared plus k, where h is equal to negative 5 on 4 and k is equal to negative 49 on 8. This part was really supposed to happen in your mind, but you can feel free to write it down for working. And that's it. Isabella giving us some key points here. Factor the coefficient of a, add in b squared and 2a squared. I don't like to give the formulae, aka b squared and 4a squared. Take back out that. In the video here, I gave the formula to kind of help. Take back all that, multiply the x term by 1 and by half. Yeah, arrange in the form right. So cool. So I actually went through everything. Everything that you need to know here is here. I believe I mentioned everything, and I didn't use formula to talk about these things. You point them out. So you can try this with anything and it would work. All right, it's time. It's time for formula method. So the formula method is a gift. How do they say it? A gift from the gods. It's a gift from above. Let's use it like, let's say that. A gift from above. Why is the formula method a gift from above? We're going to take the same equation up here and we're going to transform it into this down here by just use of formula. So let me paste the equation, paste, bang. And the idea with this is that I am going to give you some formulae now for h and k. What are the formulae? H, and you're going to write it just like this. H is always going to be b on 2a. And k is always going to be 4ac minus b squared on 2a. On 2a? Something though? Yeah. What is something like that. Let me hope I correct. 4ac minus b squared on 2a. Is it 4a or 2a? I think it's 4a now. Yeah. How I write this? Minus b squared on 2a, 4ac. There's another way you can write this, c minus b squared on 4a. C minus b squared on 4a, 4a switch, yeah, so it's 4a. Switch this to a fraction, 4a, 4ac minus b squared. Yeah, always sorry about that, the Quadratics, the sugar and thing, you know. Don't drink sugar before your exam. So that is UD. 4ac minus b squared on 4a. Now, this is a method that should be taught in school, and a lot of schools will teach it, but some teachers, I think some teachers just, I don't know, I feel maybe it could be ego. I'm not going to show my child this way. I want them to have to learn the natural method and they must fight up. I had to fight up in school, so them must fight up too. They must fight up with this. And not all students really about this life. You kind of need to like maths on a certain level to be about this life. So if you're about this life, I'm here today to help you out with this method, right? So this is actually just giving you the answers. All you need to do here is memorize these two formulas. And you have to be a very lazy person to be thinking right now, I cannot memorize them formula. It's too hard thing. This formula can be memorized by every last one of you here in minutes. What it is to memorize H is equal to B on 2A. The reason I'm saying this is when I used to do a lot of private teaching in one-on-one people, and I tell them they had to memorize the formula, they're like I just cuss them about their mother or something. What is this to memorize? You could write this down a few times and you'd learn this, and then write this one down a few times and you learn it. Are you afraid of a negative sign? Are you afraid of the squared? Do you want the 1? Do you want the 2? All right, so memorize them formula for my people, and all you need to do now is substitute. B is -5, so I'm going to put -5. A is 2, so I'm going to put 2 by 2. So you get -5 on 4. Wait. This is the same number from here. Yes. So yeah, we just get the answer straight up from, that's what the whole formula method is about. And then K is equal to 4 by 2 by -3. Where am I getting these numbers from, by the way? This is A, this is B, this is C. Now, so don't forget the sign, eh? Don't forget the sign. Sign belongs to the number. And minus B squared over 4 by 2. And I don't know about earlier, but that's supposed to be 49 and 8. Was it negative? Yeah, it was negative. It was 2 negative things. So yeah, and this is going to be negative here, and this was a negative there. So yeah, -49 and 8. How y'all feel about that? Because you get -24 here, negative, and 25 there. Negative, subtract 25. Why is in the chat if you understand everything here? Anybody have any questions on this? This is the formula method. You're kind of done there. You're kind of done. Let me show you how you're kind of done, eh? So you write this, and you write out this working nice and good for them, like that. Settle your thing. I like to tell my students, write it in the same pattern. There's a reason I'm doing it like this. It makes it easier for students to memorize. When you put the H here, the K here, and you write it down. There's many things in AdMaths and Maths that work, like where you put 2 on the side and you work down. Determinant and adjoining matrices is one like that. And then, what you're going to do with your life now? You say, therefore, you write back A, because remember, you want it in the form A, 8x plus H to B squared plus K. And you just start to fill in the blanks. You play in a game of filling in the blanks. A will always be A. A is 2. You put the X now. X. What to put now, boy? Plus H. H is that. -5 on 4 to be squared plus K. And I'm not just going to put plus K. I want to see the sign. So since it's negative, I just put -49 and 8 one time. And I good to go there. That's the answer. You write it in the big boy way. Therefore, you could put this is equal to that, where, or you can say this is in the form A into x plus H to B squared plus K, where H is -5 and 4, and K is -49 and 8. Formula method. My maths teacher say this method is sacrilegious. If you can't memorize it, just look at the formula sheet and break it up from the quadratic equation. That's a good idea. That still requires some skill, boy. That still requires some skill. Every single thing from the first method to the second. Oh, Michelle, you understand everything. And anybody else? Go over the natural method again. We love this method. Go over the natural method again. We love that method. Our math teacher used to do it sacrilegious. It's not really a math teacher or English teacher. All-time math legend, Corinne Springer. Yeah, bless her. So this is how you complete the square using just formula for K, H, and K. And it will work for anything. One last method. About to really change the game on earlier here. About to make it really easy. So I'm sorry for the people that just sneak out, because I'm about to bring it even easier. The last thing that I want to show you is that, my gosh, you can do this on your calculator. So your calculator will start off like this. Where the My thing, boy. Just bring him down to suit day. Just give my little second there, and I'm gonna just bring this across. So bring this across. So and bring this up. Right. So your calculator start off so, right? Nice. You could solve this and get H and K on this calculator. Once again, this is the Casio FX115ES Plus. This is a normal scientific calculator, non-programmable. So you're going to press mode. You're going to press equation, which is 5. You're going to press number 3 to bring up the quadratics. And then you're going to put in the coefficients. 2, 5. Oh, it's -5 and -3. ABC, right? ABC. Then the next time you press equal, you will get the it's supposed to be me alone in this building, and I doesn't like these noises and thing here. You will get the well, you see, I forget where I reach. Yeah, I just put in all the coefficients and thing, and when I press equal now, I'm just going to get the roots, and then something else is going to happen. So I get the roots. X1 is 3. Remember, we do this already with the roots and thing. X1 is 3, and X2 was -0.5. Now, when I press equal again, magic. The minimum point, 5/4. Where does this look? I have negative here. And that's correct, because the minimum point is -h. So all I need to do is change the sign on this, and that will be h all the time on your calculator. The x value of the minimum point, x value, the x value of the minimum point, change the sign, and that's h. And the y value of the minimum point is just k. So the next one is just going to give me -49 and 8 k. So you just take these values and you can just plug that straight in there. You can just plug that straight in there. Now that for sure would make you lose a mark because you have 0 working. You need to show what you do. But you could. What I tell my students to do is use this to verify your answer. You catch where I'm coming from? Anybody on Facebook right now? Anybody viewing this on Facebook? I know it have 431 people on YouTube. So you have -49 on 8. So this is how to do it on your calculator. Minimum value, maximum value. Okay. So once again, if you don't have that on your calculator, well, organize yourself and get the FX115ES Plus. I assure you. Just go and search this on Quadrant Technologies. Before I used to say I have no affiliation with this guy, but yes, I talk to him and thing now. And every now and then he's giving me a free calculator to give away to students, and I just give it away. So I gave away 2 to my AdMaths class 2 weeks ago. And again, I guess I'm about to give away now. So, all right. So you could go and check this guy out if you're from Trinidad, or you could just order it online. The FX115ES Plus. There's a version 2 now. Or you could get the class with Casio. Both of them is Casio. So these calculators are really good for what we do in this region. Really good. The class is, I think, it's FX911. Some I don't want to tell you the wrong thing, but it's called the class with. Okay. I'm gonna write. I use my calculator for working. I use my calculator. Just get them the answer. All right. So, sir, that was intense. Are we finished with quadratics for CXE? No. You see, as I said, after you complete this square, there's more. So, you just had a labor in the vineyard, complete the square, and then after you complete the square, there are a whole heap of questions that they can ask you about. But there's hope. I am here to guide you today on how to be able to answer these questions. Because, I don't know if you remember, just now we was doing, where the decimals graph thing? I delete it. All gone. Just now we brought up this graph. And we created this equation. Let me create the same equation I have here. What was it? 3x squared. Forget it earlier. 3x squared. No, it was 2x squared minus 5x minus 3. 2x squared. 2x squared minus 5. This will really help you to understand this with this graph showing up here. Plus 3. And I want to it was minus 3. Minus 3. Yeah, so this will really, really help you to understand this topic if you're struggling with this. All right. I'm just trying to organize it up in the best way possible. Hopefully that was good. Cool. Remember I said there are 3 important points on the graph. There's the part where it cuts the x-axis, the part where it cuts the y-axis, and the part where it makes the turning point. In this case, it's a minimum point. So these are the questions that they will ask you about. As soon as you finish complete the square, big man, they're going to ask you about either this and this, which is called the roots. If they ask about that one, you can share that here because this is the longest one. If they ask about the roots, I mean, your calculator will give you the answer. So you always have your calculator to fall back on to know if you make a mistake. But the working faith, when you complete the square, the roots will be the longest one. They could ask you about the y-intercept. If they ask you about this, smile, because there's 3 marks. You could just read this off of the first, what it was. This is the y-intercept. The equation itself has the y-intercept in it. 2x squared minus 5x minus 3. This negative 3 is the y-intercept. It's negative 3 you see in there. So that's the easiest thing they could ask you about. People, let's lose this marker. People, let's go to the completed the square form. People, let's try to say this is the y-intercept. Like madness. This is not the y-intercept. The y-intercept is this from the first equation. Okay, so they go back. So that's the y-intercept. And then this point, most of the questions will be revolving around this. What's this called again? The minimum point. Or the turning point if you want to talk about it in both ways. So the minimum point, they're going to ask you a question or that. Are you ready to learn how to answer the questions? You just complete the square. They are going to ask you something with relation to 1, 2, or 3. They can ask you, I know some people who doing this before know about this, the line of symmetry, but I like to relate that to question 1. They're really asking you something on this. Now, this one is kind of split into 2. They could ask you stuff involving the x coordinate or stuff involving the y coordinate. So we're going to begin at 1. Let's start off with 1. What are the questions that could come out of this first part, this minimum point, after you just complete the square? So, turning point questions. Stay with me, Alice. Stay with me. Turning point questions. So, you just completed the square. You went from this to this. And now they're asking you questions about the turning point. What can they ask you? Let me tell you. So, we just completed the square earlier. We have this. They can ask you stuff like, what is the coordinate of the minimum point? What is the coordinate? What are the coordinates? This is not English class. They could ask you that. They could ask you, what is the minimum value of, and they might say f of x. Like they might have write f of x from before that equation was f of x. All of these are really asking you about the same thing. They could ask you, what, and keep in mind, if it was a maximum, this would have been max, right? But it's a minimum. What is the value of x when f of x is at is minimum, or what's the value of x when f of x is at the minimum point? Or they can ask you, what is the equation of the line of symmetry? Symmetry is a weird word to spell. I hope I have it down. I can double check that spelling for me. So these are all the questions. Now keep in mind, this question and this question can be phrased differently, but they're really talking about the same thing. they can phrase what is the minimum value of f of x, what is the value of x when f is at the minimum point in two different ways. So I'm here to just burst the answer open right now to you. All these questions are talking about one thing, the coordinates of the minimum point, this. All of these questions are just talking about one aspect of it. So negative hk is the coordinate of the minimum point. So me put it up already. Negative hk. What does that mean? Well, this is h, this is k. The coordinates of the minimum point in this case must be 5 and 4, 49 and 8. Well, negative 49 and 8. And we could go back to our little graph too and see that too, you know. Friend, this is the coordinates of the minimum point. What do you think negative 6.125 is? And what do you think 1.25 is? This is negative 6.125 and this is 1.25. They're just using decimals. That's the coordinates of the minimum point. This is literally the point where it is turning at. And this is what you need to remember. The coordinates of the minimum point is negative hk. Now you might be saying, so this question asking about that too? Yes, technically yes. It's actually asking less. It's asking you less. It's asking you what's the minimum value of f of x. What is f of x? Y. F of x is the y. F of x is the result. The output. Y. So what is the minimum value of y? K. The y coordinate. The minimum value of y is k. So this one here is negative hk. Now, I don't want you to write negative hk in the exam. You ain't gonna get it out. You have to write negative hk and then put what negative h is. Switch the sign on this. Put what k is there. And that's the answer. This one will always just be k. All you understand what I'm saying? This one will always be h, negative h. What is the equation of the line of symmetry? The equation of the line of symmetry. This is just x is equal to negative h. So they basically saying x is equal to that. Just write x equal to that and you get your answer. So let me write the actual answers in blue here. So we have 5 and 4, negative 49 and 8. So you just write this and then you fill in the blanks. What's the actual answer? What is the minimum value of f of x? This must be k. K is negative 49. So minimum value of f of x is negative 49 and 8. Why is in the chat if you're understanding? What is the value of x when f of x is at the minimum point? Negative h. Just write that back. Now keep in mind negative h is an indication that you need to switch the sign. So don't go and put negative 5 and 4. You must switch the sign. So it's actually 5 and 4. Yeah. What is the equation of the line of symmetry? X is equal to negative h. So the equation of the line of symmetry is x is equal to 5 and 4. This is a good time to point out. I just take it for granted that sometimes as a math teacher, when you're teaching a topic like dozens of times in the year alone, and then multiply that by your 10 years or 15 years experience, it's kind of take it for granted certain things, right? Take for granted certain things. In completing the square, we keep the number as an improper fraction. Don't go and decimal up the place here. Most things in maths, as the higher up you go, you try to stay in fraction land. Is work out best that way. And people hate fractions and they like to switch this to the decimal as fast as possible. No. Keep that as a fraction. Good thing. Good advice. Right? So, and that's this point. So that's the coordinate of the minimum. So that's 1. What about 2? The y-intercept. I already mentioned that's the y-intercept is just the c. When you have ax squared plus bx plus c, the c from the original equation. Not this number. Eh? This is not c. This is k. So the c in this case is the y-intercept. Easy. And the roots, as I said, the roots is the longest thing to do. So it's about time to learn how to do the roots. Take a little stretch, yeah. 2 hours pass already. We're going to learn how to do the roots. How to get the roots here. How to get roots. How to get the roots. Fine. So you're going to put the equation you're going to equate it to 0. Oh my gosh. My pen battery died. Don't worry, I can write with my finger for the little while until it charge back. So, but my handwriting going to, sweet my handwriting was looking. See how lovely it was looking? It's going to actually get worse. So, put this equal to 0. And this is where you need to do some action. So to get the roots from this form, to show how the working to get the roots from this form, you can use a calculator to verify to make sure you have the correct answer. And I'll already show you how to do that. It's still on the calculator here. X2 is one of the roots. X1 is the next roots. I already show you how to use the calculator to get the answer for everything. If you missed that and you just come in, well. Yeah, so we reach here, write the quadratic in the completing the squares form. It's equal to 0. You're trying to see where it cuts the y-axis, x-axis, sorry. First thing first, bring across that number. Oh gosh, my finger gave me some action here. So 2x minus 5 on 4 squared equal 49 on 8. Why isn't it chat if you understand what happened there? So I brought across the 49 on 8. Yeah, right? Nice. And it turned positive. And what next? What's next is that I have to bring across the 2. The 2 is multiplying this side, so when I bring it across, it will divide this side. It come like it multiplying on the underneath here. Or it come like it's multiplying by 2, so I multiply by a half, or I divide by 2. Everybody catch that? So in the end, I hope you can see that will end up with something like this. I brought across the 2. The 2 is multiplying on the side. If I divide both sides by 2, this will turn to 16, the denominator. Now I need to get rid of the square root. This is where I'm starting to reach into some good action now. So to get rid of this square, I'll need to square root both sides. So I need to square root this and square root that. So I'll end up with the square root of 49 on 16. But since we're dealing with quadratics and we're in this stage of mathematics, we have to put plus or minus. Because remember, you get 2 answers for x. Plus or minus root. Well done, Dinel. Well done, Rahil. Well done, Samir. And then, last piece, well, kind of last piece, you bring across this last little bit here. Now, we just notice when you completed the square form, don't go and square this and multiply this, and you'll be going backwards. You need to start off by bringing this number across, this number, and then getting rid of the square root. All the time, it's always work out like that. Practice it. And then you get x is equal to 5 on 4 plus or minus the square root of 49 on 16. Even if you're feeling like I am not a big math student, all these people who put out answers, this is not really me, I can't do this. Yeah, you can do this. I've taught people who 50-something repeated maths for 5 times and thing, and they eventually understand this and they replicate it in the exam. Just practice. Just practice it. What's next? The last step is just finding out what will happen if you add it and what will happen if you subtract it. So you're going to literally put 5 on 4 plus the square root of 49 and 16. By the way, the square root of 49 and 16 can be worked out. That's 7 on 4. Square root of 49 is 7. Square root of 16 is 4. So you add it 5 on, and what you get 3, and then you subtract it. And when you subtract it, what you get by? Negative a half. Negative a half. That's the 2 answers we get for the roots 2 from the calculator. Negative a half and 3. You understand what I'm saying? So it's either x is equal to the 5 on 4 plus the 7 on 4, which you get 12 on 4. 12 on 4 is 3. Or I do the subtraction version. 5 on 4 minus the 7 on 4, which will give me negative 2 on 4, which is negative a half. And that is it. That's the entire of completing the square there. Everything you need to know for CXC, completing the square. Since we talk about roots here, it's time for me to introduce roots back to the early, easy stuff we was doing from before. I will never have it up here. Remember when we do these before? And we reached this scenario here? When we reached here? If this equation was equal to 0 and they say solve, you'll find the roots, and it will be much easier to find the roots. What you're supposed to do is say either, you all remember doing this in school, x minus 2 is equal to 0, so x is equal to 2, or 3x minus 2 is equal to 0, so 3x is equal to 2, and x is equal to 2/3. So this is like how you find the roots when you're after you've factorized. How was that for you? So rate how much you understand everything we do today out of 10. Anybody was here from the word go? Well, I know I've seen some people name here, write you. Rate how much you understand everything we do here today out of 10. We did the basics in quadratics. We did how to factorize, how to identify the ABC. We did difference of two squares. We did graphs. We talked about the graphs. We talked about completing the square. We did everything in completing the square. The only thing I didn't really do is sometimes is actually to draw the graph. And although I show you all the information you need to draw the graph, I didn't actually do it. And as we come in, I think what I can do is on Tuesday, I will have, on Tuesday, I will have a part 2 to this, where I will just be doing past paper questions. So like I taught all the theory today. I didn't notice I didn't bring up no CXC paper. I just teaching from the top of my mind. So I didn't bring up any CXC papers here. But on Tuesday, I'll just line up a whole set. I'll tell one of my tutors to just organize a whole set of completing these square questions, and we'll go through it, and you get to see it in like the practice mode. So gears up on yourself. Tuesday, I'll have school though. And it have a curfew. When is the curfew in Trinidad again? And I hear something about 7 p.m. Some talk about 7 p.m. and all kind of thing. That's just for the weekend. So I had a bus out here before 7 p.m. So I think the curfew is still 9 on Tuesday. So maybe I could start right after school, like around 3. Around 3 to 3 till. It might be an hour, 2 hours of completing this square. Maybe a little more practically. Our next mini marathon session. Now, my plan was to go into the add maths, but I just realized that will mess up because half the people, more than half, just going to leave the chat immediately once I start talking about hidden quadratics and things. So what we gonna do, boy? What we gonna do? Maybe I could stop this video and start back a next video with add maths. Or maybe I could do add maths on Tuesday too. For sure, I'm not doing it in the same video. So if I let's see me come back online, I'll do the add maths one time. But I feel I just run through the whole of quadratics here. Let me just verify that I touched everything I want to talk about in quadratics. Instagram. Hey, look, Morgan Freeman, boy. Hey, look, Nival, boy. Nival, where's he? And quadratics clinic. We talk about the general form, factorizing, completing graphs, solving. Oh, we didn't bring it up in simultaneous equations or inequalities. So we're just gonna talk about it in simultaneous equation and inequalities, which is not as hard as you think. It's just learning how to adapt the simultaneous equation and attach it back to what we learned before. And in inequalities is learning which inequalities have a little thing. So stay with me, people. We're going to just spend 20 more minutes and we're going to wrap up this section. And advanced people need to know all of this, plus hidden quadratics and some products, which I'll probably do on Tuesday or Wednesday. Monday afternoon, I have maths class. All right, so let's waste no more time talking about that. Let's just get the two things out of the way. Simultaneous equation and inequalities. So let's talk about the inequalities first. That's really important. Let's talk about the inequalities. So you would have heard, and this comes in CSEC maths. It can show up in CSEC maths. You would have heard about NASA, go over the add maths. I'm here for add maths. I'm here for add maths. No, I'm here for add maths. Let's do the add maths today. Let's do the add maths today. All right, well, fine, we'll do the add maths today. Why isn't the chat for you? I could do the add maths today. Add maths people. Add maths nothing. So let's do the add maths. I see, excuse me, some wise. A lot of wise. So we have a lot of add maths people. Well, we can see if there's a lot when I introduce the add maths section. All right, so we'll go ahead. All your energy. I can match it. Inequalities. And this really helps for add maths people as well. Inequalities with quadratic. How does it work? Well, you would have heard about inequalities like this. You probably would have heard about inequalities like this. Let's say you had this. Can you solve this? Can you show this on a number line? Can you shade this graph or something if you have to? Yes, you can. Yes, you can. So you bring across this and you treat it just like any a normal equation, right? And then on a number line, you have like your 4, 3, going up the road, 5, 6, 7, blah, blah, blah. And you put a circle here and you don't shade the circle and you want it greater than, and you do this. You all would have heard about that. Everybody here can do that. Every man jack here can do that. And you know the tricks too. You know the tricks? The tricks happen like in cases like this. Like if we have maybe like 10 plus, let's say we want what we want by, let's say we want 4x here, and is, let's put equal there, and let's put like 7x on this side, and let's put like what, 6 on this side. Let's put 5 on that side. So you can do this. Can you do this? Do this quickly and put the answer in the chat for me. So you must understand your little basic rules of normal inequalities before you go into quadratic inequalities. Can you do this? Can you show this answer on a number line? That's what CXC like to ask you when they finish. Show on a number line. And can you show it on a graph? Like if you have a graph, can you like draw the line and then shade and that kind of, you know how to do that on the graph? You know your thing? All right, so there are 2 ways that students are doing this right now. Some students will be bringing across the 7, so you'll have like 10 plus 4x minus 7x is less than or equal to negative 5. So you have negative 3x is less than or equal to negative 5 plus 10, and you bring the 10 on that side. So you line it up like that now, boy. And this is not what I wanted to do. Oh, yes, because when I bring across the 10, it will turn negative. And then you get negative 15. And then you reach a stage in life where you're going to activate the sharing gun. You're going to see something pop out here that you know you're not supposed to do. That's, well, so, there's a procedure here that happens here. You activated the trap card. The trap card says that if you divide off by a negative number on both sides, and that's what you're going to do, you're going to bring across the negative 3, you need to swap the signs. Just the process of dividing by that negative 3 means you need to flip the sign like that now, boy. And then you continue on like normal, and 2 negatives will make a positive, so you end up with this, which is what I'm seeing in the chat, but I've seen some errors too. Right? So we have this in the chat. Another way students would have done this is they're seeing that if I bring this across negative and bigger, no negative, so let me bring this across now, boy. And then I'll bring this across. So they see that in the mind, so they proceed. So they end up with something like 10 plus 5 is greater than 7x minus 4x. So that's looking good. And they end up with the 3x here, and they end up with 15 here. And then some students, some naughty students, would say maybe 3x. They just do that, which is no. That's a big no. You don't do that. If you swap both sides, once again, you have activated the trap card. The sharing gun. You have activated a situation where you need to switch the sign as well. So time to switch you, bro. You can be facing that direction. In other words, this was on the pointy side, so it has to remain with the pointy side. You understand? And then you bring across the 3. So you have like this. 15 over 3, and you end up in the same situation, 5. Or some people will just keep going here, and you'll end up like this, 15 over 3 x, and you end up like this. And this, believe it or not, is saying the same thing as this. This is saying 5 is more than or equal to x, and this is saying x is less than or equal to 5, which is the same thing. It's the same thing. And if you decide to swap it around, yeah. Hey, the men talking about Logan Paul. Hey, that fight going on today. Logan Paul, Floyd Mayweather. All right, whatever. Yes, let me focus on getting secure in the bag, and like Logan Paul bag secure already. So let me secure we bag, right? Right, but this is not what we're here for. We're not here for none of this. We're here for quadratic inequalities. So let's use one of the quadratics that we had from before. You mustn't waste quadratics, you must recycle them. What's one of the quadratics we had before? Which one? I feel we could take this one, the first one. Bang. So we have this, and now we're gonna make it an inequality. So let's just do this. I'm just throwing natty. So it's an inequality now. No, let's not do that. Let's put a 0 here. Let's put a 0 there. Right? So it's an inequality. So what do you do, sir? Well, firstly, I want to tell you here today that your calculator can solve this. Yet again, your calculator can solve this and actually give you this solid, straight up answer. No tricks, no chat. I'm telling you, no cap. it's just straight facts are given only here. Where my thing gone? Oh, look at here. Your calculator can actually solve this. Very few maths teachers know this, much less students. Most scientific calculators, non-programmable, allowed in exams, can solve this. Let me show you how. So your calculator will be facing you in this mode right now. Maybe it might be in radians, maybe it might be in degrees. You're going to press mode. You're going to go down. And you're going to see inequalities watching you because you have the right calculator, right? FX 115 ES plus. You're going to press 1 in inequalities. Press 1. And you're going to select 1 for quadratic inequalities. Then you're going to select which style of quadratic inequality it is. Oh gosh, I didn't mean to do that. So it's looking like it's the greater than or equal to. That's 3. 3. Then you're going to type in the numbers. 2. Negative 1 is B. Keep in mind when you see no number, it means 1, right? Then 1. Press equal. Oh. This is a bad example. This don't have no real roots. Wow, and the calculator even tell you that too. But yes. So it's greater than 0 every way. You understand what I'm saying? Did I type in all the correct numbers? 2, negative 1. Oh, I didn't type in the correct numbers. So but if this happened, what the calculator is telling you here is that this is happening. It didn't cut the, so it always it's always greater than 0 forever and ever. But it's supposed to actually be negative 1 hereby. Negative 1 hereby could win by negative 1. And there you go. The calculator is giving you the answer. X is less than or equal to negative a half. And it have this kind of back to front. So I would write it like this. X is less than or equal to negative a half. Or, and you notice that comma there. You notice I have a comma here. That means it's two separate things, right? Or X is more than or equal to 1. You notice how I flip it. I flip it around, so I had to flip around the sign. Casio for your money, boy. Casio just gain your things out here. So yes, you can just solve this on your Casio. But you need to know how to solve this all the way down. So how do you solve this all the way down? Well, this is what you do. You factorize this first, and you already know how to factorize this, right? So 2x squared, I'll go through the nice long way here. And you want negative 2x plus 1 x minus 1. And that noise in the background that I'll hear, and when I'm listening over the recording, I'll be hearing it balling. So I don't want nobody to think like I have somebody, trapped here or something. That is the neighbor parrot. The neighbor parrot is beginning on so. Anyhow, so 2x into x minus 1. X minus 1. We do this already. For today. So 2x plus 1, x minus 1. We factorize. So all I did was factorize like normal. I end up there. So what's next? The next step is to treat this as if it's equal to 0. So find the roots. So you say when f of x or whatever it was, maybe they would have called it f of x, maybe they didn't. So you can't just train f of x if they didn't. So you would have to say when this whole thing, and you write it out, when it is equal to 0. When it is equal to 0, whatever, right? When it is equal to 0, y'all understand what I'm saying? You're treating it like if it was equal to 0. When it is equal to 0, the roots are, well, 2x plus 1 would be equal to 0. And the idea with this, when you're solving a quadratic and you have it equal to 0, if you multiply two numbers and you got 0, it means one of the numbers was 0. Is either this one or 0, or this one or 0. So these are the two roots, 1 and -1/2. Now you just draw this. Remember, what I'm teaching you to do is to solve quadratic inequalities. If it's a minimum, you draw it like this. If it's a maximum, you draw it like this. You draw this and you draw the line across. You put the smaller number here and the larger number there. The smaller number in this case is -1/2. The larger number is 1. Why is in the chat if everybody following me up to here so far? You set up your inequality, solve like normal, reach up to here. This is the first new thing I'm teaching you here. You draw the graph. You don't even need to draw the y-axis. Nobody cares about the y-axis. It's somewhere here. You don't need to draw the y-axis. You can just draw the x-axis and write the points. Now keep in mind, if we had get something like -3 and 2 as the answers here, the -3 going here, not here. -3 is actually smaller than 2. Just saying. All right. And now you ask yourself, what is the region? What is the inequality that satisfies this for me? I want to be satisfied. I want my graph to be above the line y is equal to 0, above the x-axis. You can treat more than as above. Where's the graph above the 0? 0 is this. Above will be positive numbers, you understand? So where's the graph above? Well, here and here. Not here. It's under there. It's above this direction going so, and that direction going so, for on and on, forever and ever. So how do we write that? You see, when x is less than or equal to -1/2, meaning as I go this way, or when x is more than or equal to 1. And that's what the calculator gave me long time ago. And that's the answer. That's it. That's quadratic inequalities there. Now, it could be a little different. It could come like 4 different ways, because it could be a minimum, and they could probably be asking you for the area under the graph. If this was facing this direction earlier, stay with me. If this was facing this direction, what do you think would have happened? We'd have be talking about this area here when it is under the graph, and we'd have to writing it in blue. We'd have to write it like this. X is in between. This is how you show it. Like that. That's what you had to do. Graphical method, fully recommend. Quadratic inequalities, there's another way to do this. There's another way to do it with the plus and the minus and thing. But I just recommend the graphical method. I find students just gravitate to this. And you have to know the graphical method. Anyhow you take it. Certain things you can be tested on when you have to know the graphical method, especially if you're doing ADMAT. So you might as well just learn this and solve all your quadratic inequalities with this. This video will be posted. So that's quadratic inequalities in a nutshell. I didn't do plenty questions here, and as I said, I'll be doing some practice questions on Tuesday. The last thing that we need to learn to stay in the realm of CSEC maths is what happens in the case of a simultaneous equation. So how to say this, boy? Just give me 1 second, right? So I just write in simultaneous equation here, and I need an example, but I need to make it. Firstly, I need to make this example. Hold on, I'm coming through just now. So hopefully this work out. If you go back, that. Yeah. So what can happen in CX is we know simultaneous equations, right? And you have the elimination method or you have the substitution method. But this is when we normally activate like the elimination, especially when we have two linear equations. What do I mean by linear equations? You know, when you have something like 3x plus 4y equal 11 and then x minus 2y equals 7, and then you need to make this match up and subtract. And you all know what I'm talking about? You know what I'm talking about? That kind of eliminating thing, and you find for one and then you substitute back in one of the equations and you find for the next one, right? That's two linear equations. There could be a situation like this. This is not a linear equation. When you multiply two variables by each other, think of this like if this was x. X by x is x squared. It goes into a non-linear equation. It's not linear. Linear means the power of x must always be 1. The power of the variables must always be 1. So this is bacchanal in the courts here. So I want to share. This is an easy one that I want to share how to solve. And hopefully when you come in on Tuesday for we session at 3 o'clock. By the way, there's like 3 lessons here, so I'll just pay use by pressing like on this video for me, please. Close off the chat, press like, and then come back on. You close off the live chat, press like, and then open back the live chat. So you have equation 1, equation 2, and is a little bacchanal in the courts if you try to it didn't really have nothing to do the elimination method here, as far as you know. What is this? Where is this? So the idea with this is that there's a non-linear equation. Linear just means line. This is the equation of a line. If you rearrange it, is a line. It will form a line. This soldier here is actually form a curve. It's non-linear. And this is the linear equation. We are accustomed to solving two linear equations. But if you have a scenario, and this can come for CXE, and it comes for CXE more 40% of the times, it can come for CXE, especially in the section 2. How do you solve it? You want to use substitution right down the road. So you want to substitute, write this down. Substitute the linear into the non-linear. So you must be able to spot linear, non-linear. Make somebody hear the subject of this formula. Why looking good? Why looking very good right now? Make him the subject of the formula and chuck him in the non-linear equation. Let me show you. So from equation 2, I could deduce that y is equal to 2 minus 3x. Why is in the chat if you see how I get that? I just bring across the 3x. So y is equal to 2 minus 3x. And now I want to take that 2 minus 3x and put it in place of the y here. So how do you write that? And you must write these things. Must write. Practice, people. Practice. We write substituting for y in equation 1. You can write something like that. Or substituting and write over this whole thing. Or placing this as y in anything. Just make sure you write some good information there. So 2 minus 3x is going to replace. And I want... I see it to turn the page and all kind of thing here, right? Anyhow, so we come back with equation 1 now, and xy is equal to -8. But instead of y, I want to write that. All you remember what topic we're doing today, right? What's the topic we're doing today, Alia? What's the topic we're doing today? Quadratics. That's why I'm talking about this, because you're going to end up with a quadratic. You have to multiply these things, and you'll get 2x minus 3x squared is equal to -8. And then, when you bring across the 8, you'll end up with 8 plus 2x minus 3x squared is equal to 0. Or some of you all don't like this negative coefficient here. Or you don't like that. Or you don't like some students. I hate to see that. I hate to see it. We don't want to see it, sir. We don't want to see it. So if you don't like to see that, fine. You can bring it on the next side. You can say, let me go and join the 8 now. So you bring it across this way. Just don't forget that this would switch signs too. So you notice that switch sign too. And then you just solve with the grace of God. You take a little prayer on yourself, and you're good to go. Not do that. You're not good to go yet. You still need to get other things. Let me go through. So when you're solving this, 3x squared minus 2x minus 8 is equal to 0. What are we going to do? Quadratic, you're solving normal factorizing. Don't use no. There's very rare that you'll have to use the quadratic equation ever in life. That's very rare. Like, let's just use 1 or 2 special occasions where they're basically asking you for something. Show that x could be expressed as this, and that's the only time you use the quadratic equation. Other than that, you're either using factorizing or completing the square most of the time. That's what they want to see. So I just let you know that, by the way. If your teacher loves to make you use quadratic equation, most of the time, pure maths, add maths, university maths, very rare that you have to use the quadratic equation. Anyhow, let's factorize this. So 3 by -8 is -24, 2 numbers. So we're looking at -6x and 4x there equals 0, right? And then we can say 3x could come out there, and we get x minus 2. You put x minus 2 there, stamp it there one time. You put your plus 4 here. So you get 3x plus 4, and x minus 2 is equal to 0. And then either, when you equate these two to 0, you'll get x is equal to -4 and 3, or x is equal to 2. I kind of speeding because I taught this part already. I just really want you to understand that when we do that, we're going to end up there. Now, did I do this correctly? I see no kind of different thing. 4 and 2, is that 2x? Why are I seeing different things? No, I'll just make mistakes. Okay, fine. Yeah, pay attention to this. I see too much different answers in the chat there. No, it's a long question. A question like this will go for 3 or 4 marks. And the reason it's a long question, yes, you did the substitution part. Then you had to solve a quadratic part here. And then guess what? You ain't done yet. You get 2 answers, so you're feeling like you're done. Or those 2 answers were x. We still need to get the y. And the fastest way to get the y is to put the x in one of the equations. And I find personally that this equation looking very nice to put the x in. So you would say substituting, or when, use the word when x is equal to -4 and 5. That's one of the values, right? 4 and 3. What's going on here? -4 and 3. Who I read that from? Michelle. Is -4 and 3 or -4 and 5? Why Isabella have 4 and 5? What I do? Let me have to check over this. 5, -4 and no, how you can get 5? It's 3x. Let me just run through this again just to make sure with everybody, and somebody asking to repeat in the chat. So we rearrange the first equation. Everybody pay attention. We rearrange the first equation. 2 minus 3x, right? And then we substituted it. We substituted it into this equation. So there it is. And then we expand. Oh yeah, this is the person who called us say had an answer. Yeah, still teaching. What's going on? Yeah. Right. Yeah, that's a really important call. So if so we expanded, we created a quadratic here. There it is. And we solved the quadratic using our skills that we learned and sharpened up today. And then when we factorize out everything here, we get x is negative 4 and 3. Yeah. This is 3x. I don't know. And this is x is 2. Right? Yeah. The switch sign now, buddy. So we say when x is equal to negative 4 and 3, then x by y equal negative 8 was the equation, right? Then I could just replace the x with negative 4 and 3 here. I substitute the x into the nonlinear equation, or any one of the equation I could have choose actually. It must work. And then y would be equal to, well, this is multiplying, so I'll have to divide, it will invert. So again, negative 8 multiplied by 3 and negative like that. And this will give me, I feeling a good 6 coming on here. What do you think? So can they also ask you to find the points both? Yes, so this is like that. This is like there's a curve and a line intersecting the both of them, and that's what's going on. Or it could be 2 points of intersection with a line, but that's not quadratics. That is just two linear in equations. Everybody good so far? Or when x is equal to 2, 2 by y is equal to negative 8, y is equal to negative 8 and 2, so you get negative 4. And now, therefore, you have your answers. Or if they ask the coordinates of intersection, it will be negative 4 and 3, 6, and negative and 2, negative 4. Let's just show this very quickly on the Desmos graph. For those of y'all who want to see a little extra. Yeah, so we had, we had xy is equal to negative 8. Xy equal negative 8. That's this curve. It's a really weird curve. And then we also had the line 3x plus y equal 2. So, you see what happened in here? Bang, bing, bang, bing. We just got those 2 points of intersection doing the working. So, this is a line, and this is non-linear. But the reason why this coming up in this video on quadratics is because in the process of solving it, you're actually going to create a quadratic. Something you need to practice. Once again, we'll be coming live and direct Tuesday, probably around 3 o'clock, God willing, 3 p.m. Jamaica will be an hour ahead, so 2 p.m. for them. And Belize will be an additional hour again, so I think 1 p.m. in the middle of the day or something for you. So I know we have some Belize students. And India will be in the night. We have a whole battalion from India. So, yeah. But we'll be coming live on direct Tuesday. Please God. And we'll be doing past paper questions on all types of quadratics. Completing the square, normal, baby quadratics in the first part. And even some simultaneous like this. So look out for that. I've seen people deposit leave in there. Shoes at the door and busting it. So sorry for sleeping and drinking and thing here, but this is my lunch actually. And I get the call earlier. So I would be out, and the AdMats crew who have waited so diligently, I promise I will make up for it. We will organize the AdMats. This video has hidden quadratics and taking it on the screen. It have this, and it's not in the video. I mean, we didn't actually do this today. This is AdMats content. So I will do quadratics for AdMats clinic, or part 2 quadratics clinic, AdMats or something like that. I'll organize that for you all. Please press like on the video. Feel free to share on your Instagram. Feel free to follow me on Instagram. If you're in Form 4 and you watch this all the way out, lessons to you. If you want to join my AdMaths class, if you're compatible with this style of teaching and you want to join my AdMaths class, I start over fresh in July, and I'll be teaching students for maths, AdMaths, physics, or any CSEC subject. Actually, we start in July, and we'll be teaching students for preparing for exams next year. I can't even talk too good right now. So this is the number that you need to WhatsApp to join the student hub. I want to tell you something important before we go again. I have 3 exam booklets out right now. There's an exam booklet that has all the questions, predictions for CSEC maths. It's called the Question Bank. Some of you all already buy it. You can get that WhatsApp the same number, and that's for June. That has all the styles of multiple choice that CXC asks, a custom asking for the last 10 years, and the styles of paper 2 that come in. That's a really nice critical book that I should get. As I said, people bought that book last year. Merit. Anyhow, so that's that book. Then we have the formula booklet for maths, which is that I think I'm selling that for like $70 or $50 or some kind of thing. It's just all the formulas that you could ever face in CSEC maths for CXC. You could get that by messaging the number. Just tell them, wet me the formula booklet there, so send me. I type the number in the chat, right? Let me put it on the screen. Where they? Look, Jarvis have it here. So, formula booklet, and the other booklet is the physics definition book, physics definition and formula. If there's a book that I would say really like is a boiled down condensed version, you should get that book. In fact, you should, when you get the book, write back over the book. The AdMath formula booklet is the last thing that I'm working on, and hopefully I can get that out, if not this weekend, by the next weekend. AdMath formula booklet, and that'll be really cheap too. That'll be between $50 to $100. So and that is it. That is it there. We will have CAPE classes. Once again, if you like the teaching and you know you're going to do CAPE, organizing we CAPE classes. Our CAPE classes start, the Unit 1 start in September actually. The Unit 2, if you're from CAPE Unit 1 and you're here for some reason, the Unit the Unit 2 starts in August. Unit 1 starts in September. So, Javish. Later, love and blessings. So, can you repeat what in the math booklet? There's 2 maths booklet. There's the, it's better to show than to tell. Let me just show you quick. There's a password I started typing and all kind of thing here, boy. CXC math formula booklet, where you boy? Formula booklet, CSEC, boom, bang. Get through. No. I back on. I had to download it and bring it up. Here it is. CXC math formula booklet. Excuse. All the formula for CSEC maths. Rahel, why are you messaging me on WhatsApp? So, like plane, shapes, perimeter, area of triangle, blah, 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 blah. All the formula, you can print it out and it even have all the common terms and them kind of thing. That's that. Let me show you the next one. The question bank. Question bank is 200 TT, about 180 something pages. Question bank. Last year, one of the students, called it a book comprised of happiness. Was studying for exam. He was like, wow, this is so good. This is a book of happiness. And I actually put that there. A book comprised of happiness. So the question bank has all the multiple choice, all the different styles of multiple choice that CXC like to bring. Themes, I should say, of questions. And it listed it top by topics. And we'll be doing some of this as we coming up to the exam. I'll be actually just doing it, like from the book itself. I don't care, I'm just doing it. So, but you should get the book for yourself so you can practice. And then what we add in this year is, and this took some time, sample paper 2 exams. And I did one whole one sometime recently, right? I did sample 3, and I might do some more samples from this. And this kind of based off of what was happening with CXC for the last 10 years. And here we have the solutions and the worked solutions for the samples. So this is like a revision booklet for CSEC maths. This combined with the formula booklet, you're good to go once you pay the work. And then the one that I really like, that I really enjoyed making. I mean, I enjoy making all of it, but I find like this was really, really good for students. Is the physics formula booklet, and by next year we'll have a lot of preparation booklets for students. What did you pass it for this thing, man? So the physics formula booklet has definitions, only definitions, and those of you who do physics, you'll know how useful this is. Yes, you're purchasing the soft copy. You can, if you pay online and you get through the, not today is Sunday, but message the admin now, message the number that I say now, and they would respond to you by Monday. And by Monday, this book will be sitting in your inbox. It will be sitting in your inbox if you could pay. They done screenshotting. That's okay. Yeah, so like if you screenshot this, you see everything on errors, random errors, systematic error, and the book goes through the entire C6 physics syllabus with every topic like that. This is book for revision. It's like a condensed version. So you WhatsApp this number now, organize yourself. You can pay online bank transfer. Your parents do online banking. Tell them to organize you. Or if they if you do have online banking, you have to walk into the bank and pay, it's okay. You do FCB Republic Bank anywhere in the whole of Trinidad, and you walk in and pay. Even in, people have been doing it in Jamaica, Guyana. You go into the bank and you give them the information that the admin give you, and you pay, and you get through. Or if you don't have that and you have credit card, if you don't have that and you have credit card, we shall see in the screenshotting. You're scrolling for them, the screenshotting. What the other teachers be doing YouTube lives as well? Yes. So we want to get some done from POA, POB. We will be getting some done from bio. So yeah, I have a lot of stuff coming up. A lot of stuff. The students have official classes finishing, what month we now? In June, in May. And now the teachers are just like me doing free stuff online, and then we'll start back classes in July for those who studying up to next year. Additionally, we have classes. Well, I don't think many of you will be interested in that because they're in exam mode now, but we have classes in social media, makeup, guitar, keyboard lessons, drum classes, those coming up in July. But you all could fall in when you get free time in August, September, and things. These classes are going to be really fun. This class is going to be maximum value. Everything I know about social media and marketing and making Instagram brands work and things, I've helped a lot of people make money, make a lot of money. I felt I'll be using this course to teach people how to do that, because I'll be seeing people doing all kind of things. Online boutique, and you'll be seeing them just not doing what they're supposed to do. So I can help you. If you're into those kind of things, you sign up for that course. Anyhow, love and blessings. Enough talk. Please continue the private classes. Well, it's starting back in July and Samantha. So, well, you might actually start back in September if you do keep, and we'll see all the people then. But I mean, you're on the WhatsApp group, and I see you sneaking in your sister SEA class and thing every now and then. Anyhow, later. So you're driving Lambo. Later, people. The admats, we can do the admats. You can do the admats, but not today. It was nice. This was a nice session.